Hello, everyone. Hope you all had a slight easy day at work today, right? Because we're going to spend maybe the next couple of hours discussing, algebra. So this is the start of a live, session series with GMAT Club. Um, this won't be the only video that I do. We have maybe 4, 5, 6 sessions planned. So this session will be followed by a session on inequalities. Then we'll have a full-fledged discussion on absolute values, permutations, combinations, probability, and also a session on data sufficiency. Okay, so this is what we have planned for the past, for the next say 3 months. So keep subscribing to the GMAT Club channel on YouTube. Be subscribed you to get the notifications, and hope that at the end of the 5, 6 sessions I give you enough content out there for you guys to do self studies on your own. Yes, late evenings. I'm used to it because I think I'm a personal tutor, so I do have students from different time zones. I hope you guys are up for it today. um, Let me know if things are becoming a little heavy. I don't mind giving you all a 5, 10 minute break just to catch your breath, have a glass of water, and continue, right? So I'm hoping everyone's good to go. We can start. Great. So can all of you quickly type in the chat window? Are you able to see my screen? And then we can start right away. Great. All right. So we're going to start with the topic of algebra. Okay. Just a prerequisite here, guys. I will expect everyone in this session to know the ground fundamentals of algebra. Things like, what is a plus b whole square, a minus b whole square. I'm not going to sit and list things out step by step, right? I would expect you to come with that knowledge. I'm going to start at a point, where that all that knowledge, you already all have all that knowledge, and I continue from that point. I'm going to look at algebra from a very different perspective. Rather than sitting and solving questions from the get go, I'm going to put in some structures. I'm going to put in some processes that will help you break down algebra questions in the most efficient way. Okay. So, the algebra section on the GMAT, right, does not only test you on your understanding of fundamental algebra, it tests you on decision making abilities, pattern recognition abilities. It tests you on reasoning abilities, and also tests you on whether you have an in-depth understanding of the fundamentals. So whenever I see an algebra based question on the test, I always focus on one thing. I don't dive right in and try to solve the question from the get-go. Instead, I take a step back and I observe the given question. And obviously, the question may be in the form of an equation. So, whatever equation you get, whether it's a pure algebra question or it's a word problem that you've broken down to get to an algebra form, don't dive right in. Take a step back, observe the given question, right? When you observe the given question, always make a note of the constraints. Many a time I've seen test takers overlooking certain constraints. They get so caught up in the solving of a question that they overlook constraints, right? So make a note of the constraints. I would recommend boxing them up. And always ask yourself at this point, don't again dive right in. Ask yourself 3 questions. Very important. Okay, ask yourself 3 questions. First, what kind of equation are you dealing with? Why is it important for you to know the kind of equation? Because if you understand what kind of equation you're dealing with, you will be able to figure out what concept or concepts is the question testing you on. Second, ask yourself, what is the question asking us to solve for? Figure out what the question is asking you. Don't overlook the question. Don't dive right into the equation. Figure out what the question is asking you. In more often than not, the question gives you the clue. What the question is asking you to solve will give you the clue on how you need to go about manipulating your equations. All right, sorry about that. I don't know. I think there was some issue with the share screen on that. So I shared my entire screen. So I'll be toggling between this and a PPT, guys. So let's start over, okay? Since you didn't see what I'm writing, I said that whenever you work with algebra on the GMAT, what the GMAT tests you on in algebra is not how quickly you solve the question or not how you manipulate the equations. It tests you first and foremost on your decision making skills, on your, say your process of your fundamental knowledge of algebra, reasoning, right? So whenever you see an algebra based question, don't dive right in and try to manipulate the equations and try to solve. The best thing to do, right, is to take a step back, observe the given equations. So first, observe the given equations. And make a note of the constraints that the question provides. Box the constraints up. Most cases, right, test takers don't do this. And what happens when they get so engrossed in the solving of the algebra that they forget that there are certain constraints that apply on that question. Make a note of the constraints, box them up. Second, always ask yourself 3 questions. Very important questions will help you in terms of decision making. First, what kind of equation am I dealing with? What kind of equation am I dealing with? Why is it important for me to know the kind of equation? Because if I'm able to figure out what kind of equation I'm dealing with, I'll be able to figure out what concept or concepts is the question testing me on. The kind of equation will help you figure out what guidelines you need to use to solve that particular equation. Second, ask yourself, what is the question asking me to solve? Right? Is it asking me to solve for y? Is it asking me to solve for x? Is it asking me to solve for xy? Focus always on the question in an algebra based question. Why? Because if you work towards the question, you normally would choose the right manipulations in terms of equations. And third, ask yourself, how do I simplify the given equations? Based on what the question is asking me, what is the best way I can manipulate the given equations to get to what the question is asking me to solve for? Now, how do you figure out what kind of equation you're dealing with? You can always figure out the kind of equation based on an equation degree, right? The degree of an equation always tells you what kind of equation are you dealing with. The degree of an equation is basically the highest power of the variable. If the degree of the equation is 1, the equation can be in the form of ax plus by is equal to c, or it can be ax plus by plus cz is equal to d, right? You see, the highest power of the variables here is always 1. That kind of equation is what we refer to as a linear equation. If the degree of the equation is 2, say you have something in the form of ax square plus bx plus c is equal to 0, or you can have multiple variables here as well, ax square y square plus bxy plus c is equal to 0, then those equations are what we call quadratic equations. Similarly, if I have an equation of degree 3, it would be a cubic equation, a degree 4, a fourth order polynomial, and so on. The degree of the equation determines what kind of equation you're dealing with. The degree of the equation also helps me in one more way. The degree of the equation tells me how many solutions the equation is going to have. The degree will always give me information about the number of solutions I'm going to have. For example, a linear equation will have one solution, one particular value for x that will solve for one particular value for y. A quadratic equation may have two solutions. A cubic will have three solutions. Fourth order equation will have four solutions. But, even though the degree of the equation tells me how many solutions the equation will have, it does not give me information on whether the solutions are unique or not. It does not tell us whether the solutions are unique or not. What do I mean by that? Say if I have a quadratic equation, let's say I have x square minus 5x plus 6 is equal to 0. I have a quadratic equation here. I'm assuming all of you all know how to factorize it. If not, I will deal with it, in a quick way when I work with quadratic equation separately. But let's say we factorize this. So that's x square minus 3x minus 2x plus 6 is equal to 0. So x into x minus 3 minus 2 into x minus 3 is equal to 0. So x minus 3 times x minus 2 is equal to 0. So either x is equal to 3 or x is equal to 2. These are what we call the solutions, or in other words, the roots of an equation. So you see, in this quadratic equation, the degree of the equation is 2. I had two different solutions. But if I have an equation like x square minus 4x plus 4 is equal to 0, if you look at this, this would be x minus 2 the whole square is equal to 0. And this will boil down to x is equal to 2 or x is equal to 2. So you see, I get to two solutions, but those two solutions are exactly the same. So remember, even though the degree of the equation tells me how many solutions the equation will have, it does not tell me anything about the nature of the solutions. Whether the solutions are going to be unique values or whether they're going to be the same values. I will have to solve the equation or use another process that we'll look at a little later to figure that out. So if I give you a cubic equation, right, don't be under the assumption that a cubic equation has a degree of 3. So you're going to have three different solutions. No, you can have three different solutions. You can have all three same solutions, or you can have two solutions which are the same and one is different. So even though the degree of the equation tells you how many solutions you're going to have, it does not tell you anything about the nature of the solutions. I see many test takers, especially on data sufficiency based questions, when they work with algebra based questions, right? They look at the statements and they'll say, I have a quadratic equation. This gives me two solutions, so it's insufficient. It doesn't give me one specific value. And they discard that statement. The better thing to do is for you to chase that equation and see whether it's possible for me to get to one solution or multiple solutions. Correct? So remember, the degree of the equation helps you classify the equation. It tells you how many solutions are there, but you have to be careful of it as well. Don't assume that the degree of the equation means that many solutions are going to be there. You will have two solutions in a quadratic, but those two solutions can be two same values. If it's two same values, obviously you have one solution in that entire equation, or you can have two different values. Okay with this? I want all of you all to hold on to this point before we move forward. I'm just building towards the main bits. I want you all to understand that when you work with an algebra based question, it's a mindset change that you need. Rather than diving right in, take a step back, observe the given equations, make a note of the constraints, and ask yourself the three questions. What kind of equation am I dealing with? The degree will help you do that. Second, what is the question asking me to solve for? And third, how do I simplify the given equations based on what the question is asking me? All right. Any doubts so far, all of you all? All right. I'm hoping that everybody can see my screen. My audio is absolutely fine. Great. All right. Now, let's go into. I told you the first thing you're going to do is you're going to observe the given equations. You're going to ask yourself what kind of equations. Going to ask yourself, how do I simplify these equations? So let's do the second bit first, right? Let's understand certain guidelines, or what I call do's and don'ts, while working with, while simplifying, right? Guidelines to simplify algebraic equations. What is the first guideline that I want to put in here? I'm going to speak about the do's first, right? What are the things that you have to promote while working with algebraic equations? First, always reduce equations to their lowest forms. If you have an equation 2x plus 4y is equal to 12, again, don't just leave it as it is and dive right in, right? If there is an option for you to take out something common and simplify it, take it out. So x plus 2y is equal to 6. I can simplify this, right? So whenever you see an equation, always reduce equations to the lowest form. Second, always focus on setting up equations such that they are conducive to solving, or if you're not able to solve, at least conducive to analysis. Most test takers don't do this step, right? Like I said, the habit is to always dive right in rather than take stock of what you have and then try to find out the best possible way to work. So what are the points that you would try to follow to set up equations such that it's conducive to solving an analysis? First, whenever you work with an equation, it always makes sense to keep the right hand side of the equation as 0. Whether it's an equality or an inequality, we'll come to inequalities in later sessions, but here we'll only focus on fundamental algebra. Always keep the right hand side 0, right? If you don't have the right hand side 0, pull the terms from the right hand side to the left hand side. And what do you do on the left hand side? Always factorize the left hand side, right? And always remember, when you factorize the left hand side, try to always represent the terms as products or divisions, right? Always represent it in terms of products and divisions rather than addition and subtraction. The reason for that, products and divisions of terms are much easier for you to break down and analyze as compared to addition and subtraction. Let's take an example, right? If I take this equation, let's take an inequality. AB is less than 0, as opposed to the equation A plus B is less than 0. Now, which of these two would I prefer to analyze? I would always prefer to analyze the first. I would always prefer having something in terms of a product than an addition. The reason for that is because I can analyze a product and a division much faster because I'll have to worry about signs and, if required, at some points, magnitudes. But if you look at this, the only way that the product AB will be less than 0 if both A and B are of opposite signs. If A and B are of opposite signs, that equation will hold good. And I don't need at this point to worry about the magnitudes of A and B. All I need for that equation to hold good is that A and B have to be opposite signs. But let's look at A plus B is less than 0, right? What happens there? If I need to analyze this, I need to analyze first based on sign. I cannot have both of them to be positive. Two positives cannot give me a negative value. I can have both of them to be negative. Two negatives add up to give me an even more negative number. And when both are negative, I don't need to worry about the magnitudes. They can take any magnitude as long as they are negative. But I can also have A to be positive, B to be negative. But if A is positive and B is negative, the one which is the negative quantity should be of a higher magnitude for me to have the overall result to be negative. And the same case in the other way as well. If A is negative and B is positive, I need A to have a higher magnitude than B. Magnitude is basically the number value devoid of the sign, for people who are asking what exactly magnitude is, right? Okay with this, guys? So always try to keep things in terms of products and divisions rather than additions and subtractions. They are much simpler for you to work with. And third, try to identify special algebraic properties or identities. It's important to know certain identities. I mean, I'm going to list it out anyway. So A plus B whole square would be A square plus B square plus 2AB. A minus B the whole square would be A square plus B square minus 2AB. And obviously the difference of squares, the most tested algebraical identities would be A minus B times A plus B. What about other algebraical identities? Normally, I see a lot of test takers rote learning these algebraical identities, right? So what if I give you an A plus B whole cube? How would you break down A plus B whole cube? So one way is obviously you remember what A plus B whole cube is. The second way is you can use your identities that you've just learned, the first three, you can use them as baselines to figure things out. So you can write A plus B whole cube as A plus B whole square times A plus B. You don't need, to rote learn, the value of A plus B whole cube. But if you know it, it's good. It's A cube plus B cube plus 3AB times A plus B. And if you want A minus B the whole cube, it would be A cube minus B cube minus 3AB times A minus B. Good to remember if you understand the patterns. And the sixth one, again, I don't think you need to rote learn it, but may come in handy. How would you work for A plus B plus C the whole square? So like I said, right, it's not necessary for you to rote learn these formulae. It's quicker if you know them. But even if you didn't know what is A plus B plus C whole square, try to use your baseline understanding of A plus B whole square, A minus B whole square, and A square minus B square to break this down. So what I would do here, I would say, okay, let me put this in the form of A plus B whole square. So let me call this entire term A plus B as X. So X plus C whole square would become X square plus C square plus 2XC. Right? Basically what I'm doing is I'm putting A plus B as X so that it's in the form of A plus B the whole square. And I'm opening up that term. And now I know since A plus B is X, I can resubstitute A plus B back here, plus C square plus 2 times A plus B times C, and then I can open it up. So A square plus B square plus 2AB plus C square plus 2AC plus 2BC. Right? And if you look at the pattern slightly here for A plus B plus C the whole square, it will be A square, the square on A, plus b square is square on b plus c square is square on c plus 2 times ab plus 2 times ac. You're taking all the values, 2 together, plus 2 times bc. And now if I change the sign, right, if I change, right, I put a minus b plus c the whole square, I would cater to the negative when I take the two ab's terms, right? So this would be a square plus b square plus c square. Remember, b is negative, so this would be minus 2ab minus 2bc plus 2ac. So it's not necessary for you to know these formulae. It's better you do, because it's very, once you know the formula, you can quickly break it down and work with it. But even if you don't, if you see something out of the ordinary, try to use the patterns you know to try to represent those equations in the patterns you know, and then try to break it down step by step by step, right? You can do it. You did not, you know, rote learn all of these, but it's good to know at least these 6 algebraical identities. And if you're able to identify these algebraical identities, it's going to be relatively easy for you to work your way through. Now let me give you an example here, right? Let me give you an example here, and I want all of you all to take like a good 30 seconds and tell me what would be the best way for you to simplify this. So if I give you this equation, x square plus 5x is equal to y square plus 5y, right? If I'm giving you this equation, can all of you take 20 seconds, try to simplify this and tell me what would be the simplified form of this equation, or what would be the best way for me to represent such an equation? Give it a shot, please. X plus y is equal to minus 5. Okay. So I will address to a couple of things here. X square minus y square is equal to minus 5 into x minus y. Can you simplify it further, Shubham? I see. Is it possible for you to simplify it further? Remember, try to link your equation and simplification to the algebraical identities that we have. Okay, Prachi also says x plus y is equal to minus 5. Okay. X into x plus 5 minus y into y plus 5 is equal to 0. Shweta, if you do that, is it possible for you to make the left hand side into a product? You're still left with two terms being subtracted to each other on the left hand side, right? Chill out has given me a good answer. Okay, Anusha has followed suit. Okay, so I see most of y'all here are giving me x plus y is equal to minus 5, right? So there are two flaws in the answer, okay, of x plus y is equal to minus 5. I think I'm assuming most of y'all have cancelled out certain variables, and that's something that I want to also tell you as we go to the don'ts of algebra. Follow the guidelines. What are the guidelines that I've set up? The guidelines I've set up so far are: whenever you see an algebraic equation, observe the equation, reduce the equation to its lowest form. I can't reduce it further than this. And always learn to set up the equation such as it's conducive to analysis. So good habits to promote while working with algebra would be not to randomly take things out common and say x is common, so I'll take it out, y is common, I'll take it out, and then pull it to the left hand side. No, what is the first step? Always keep the right hand side 0. X square plus 5x minus y square minus 5y is equal to 0. This is the first step I would do. The safest way of working. Now, you need to be flexible towards rearranging certain terms. Remember, what should be your end goal? Your end goal should always be to represent the left-hand side as a product or a division of values. Products and divisions are much better for you to break down than additions and subtractions. If I just take the x common here and the y common here, it's not going to set my equation up as a product. Instead, I would want to pull. Remember, I can only get to a product if I'm able to pull certain things out common. And one pattern that you always have to notice and exploit is the difference of squares. So I'll rearrange the term slightly. X square minus y square plus 5x minus 5y is equal to 0. And now I can break down x square minus y square as x minus y into x plus y plus 5 times x minus y is equal to 0. And if I look at these two terms here, I see that x minus y is common between the two. So I can factor x minus y out, and I'll be left with x plus y plus 5 is equal to 0. This is the best way to work. So you would get x is equal to y, or x plus y is equal to minus 5. These would be the solutions to that equation. What some of y'all did is you all took the y square to the left hand side, and you took the 5x to the right hand side, and then you wrote this as x minus y times x plus y, and then you took a minus 5 common, and you said this was x minus y, and then some of you all cancelled out the x minus y. This is a complete no-no. I'm going to put that as my don't, right? You will only get to one solution, x plus y is equal to minus 5. You should never cancel variables on both sides of an equality. There is a certain condition where you can do so. I'll mention that a little later. But for those who did this, it is wrong. I will mention why it is wrong. For now, I want all of you all to understand that when you're working with equations, it is very important for you all to focus on setting up the equation in the best possible way. You see, when I set it up as a product or a division, it became easy for me to break down the equation and get to all the solutions. I followed three simple rules. I kept my right hand side 0. I pulled everything to the left hand side, and I factorized the left hand side to a product or a division. Remember, products and divisions are better for you than additions and subtractions. So wherever possible, make things into products, right? Okay, with this, any doubts on this? I will explain why you cannot cancel the x minus 1 whole side on both sides. Hold on to that when I go to the don'ts. I will give you a good explanation to it. But for now, I want all of you all to keep these points in terms of the do's. One more point I would add would be this, right? I would also add one more do. Always very important point. Work towards the question. In any algebra based question, work towards the question. Don't remember, all your manipulations of your equation should always go towards what the question is asking you. Never dive right in, randomly manipulate. If the question is asking you what is the value of y, try to make y the subject of your manipulation. If the question is asking you about x into y, try to make x into y the process of your manipulation. Got it? Always learn to work towards the question. These are what I call the do's of algebra, the good habits that you need to promote while working with algebraic equations. Now, obviously, with the do's also come the don'ts. What are the things that you don't do when you work with algebraic equations? First, avoid, let me write that better, avoid cancelling variables on both sides of an equation until the variable is not equal to 0. Now, most test takers will make this mistake when it comes to algebra. Suppose they get an equation AB is equal to BC. Very quickly, they would cancel out B on both sides. This would be completely wrong, and they would say the solution is A is equal to C. Not correct. Why is it wrong? Why is this equation wrong? Anybody? Can anybody in the chat window quickly tell me why would it be wrong for me to cancel out the B on both sides in this equation? Yes, because the value of B could also be 0. Remember what you're doing by cancelling out b on both sides, right? You're actually dividing both sides by b. That's what you're doing, right? You're dividing both sides by b. But by dividing both sides by b, you're making a big assumption that b should never be 0. You can't divide a number by 0, right? Because anything divided by 0 is undefined. So by dividing by b, you're saying that b can never take a value of 0, and no such constraint is provided in the question. So it would be completely wrong for me to cancel out b on both sides and write it this way. Instead, what is the best way to work? Follow the do's. Take everything to one side. Factor out the b equal to 0. And now I can say if the product of two terms is going to be equal to 0, either b is equal to 0 or a is equal to c. This would be my solution to that equation. But where can I cancel? Where can I cancel on both sides? Suppose I'd been given the same equation. AB is equal to BC, but they told me that B is not equal to 0. They give me that limitation that B is not equal to 0. Then I can definitely divide both sides by B because I don't have to worry about the divided by 0 case. That cancels out to give me A is equal to C. So you can cancel variables on both sides provided that variable is not equal to 0. But if you don't know that B is equal to 0 or not, I will refrain from doing so. Even if you know b is equal to 0, as a matter of principle, if you want to say, I just don't want to cancel variables, I will stick to the do's, you can still continue that way. Is equal to 0, pull b common, a minus c is equal to 0, so you get b is equal to 0 or a is equal to c. And since they have told you that b is not equal to 0, I will discard this solution and I'm left with a is equal to c. So what was wrong in the previous equation when most of you all gave me x plus y is equal to minus 5? When you broke down the left-hand side as x minus y into x plus y, and you kept the right-hand side as minus 5 into x minus y, all of you all cancelled the x minus y, or most of you all cancelled the x minus y. And you got x plus y is equal to minus 5. You lost out on the solution where x was equal to y. What did you assume here to be that x minus y right cannot be 0? Basically, when x minus y not be 0 when x is not equal to y. You assumed that those values cannot be 0. So you lost out on one of the solutions. So this is something that you need to be a little careful. Alak, I see that you said for inequalities, what do you do? I will try to refrain from that at this point because I don't want to confuse you all with inequality rules. This is a pure algebra session. I do have the follow-up webinar to this would be inequalities based, which is an add-on to what we are doing. This session basically forms the foundations of our next sessions going forward. Okay, so I will tell you the inequality rules. If you're interested in that and you want to go to that, there is also a webinar that I've done some years back on inequalities. You can go there and you can have a look at it. Okay, I'll just refrain from this point because I have a lot of different test takers here. I would just want to stick to the fundamentals of algebra. Okay. So avoid cancelling variables on both sides. So if you have an equation like x square is equal to 25x, do not cancel x on both sides. Instead, pull things to one side and factorize x into x minus 25 is equal to 0. So either x is equal to 0 or x is equal to 25. These would be the solutions to that equation. Remember, it's a second order equation as well. So you should have two solutions. It need not be the same. It can be different solutions, can be the same solution, but you should have two solutions to that equation. If you cancel it out, you lose out on the 0 solution to this equation. Yes, David, this is part of a series. This is the first part of the series. Okay, so the second webinar would be based on inequalities specifically. The third would be on absolute values. All right. So coming back to this, avoid cancelling variables on both sides until you know for sure that that variable is not equal to 0. And second, now here is where I see most test takers making a mistake. Okay, and many test takers don't have a very good understanding of this. I'm going to try to attempt to give you a good understanding. I'm going to maybe challenge certain things that you've learned in school, and I'm going to blatantly say it's wrong, but I'm going to correct by giving you what the right process is. Suppose I ask you all to solve for x, okay? And I give you an equation x square is equal to 25, right? Now, don't give me the answers to it. I know all of you can give me the answers. What would you all do to simplify this equation, right? Tell me, instead of typing in what the solutions are, what do you do to get to the solutions? Can you all type that in the chat window? Understood my question, guys? I don't want the solutions. I know all of you all can give me the solutions. Tell me, what would you do to get to that solutions? You would take square roots on both sides. Now, that's exactly what I don't want all of you all to do, right? I don't want you to take square roots, because if you take square roots, then you should understand what the square root is. And if you don't have a good understanding of the square root, you're going to make a lot of mistakes. So what people will do, they take square root of x square, they'll take square root of 25, then they'll take square root of x square as x, which is wrong. And they'll write the square root of 25 as plus or minus 5, which is again blatantly wrong. What is wrong? I will explain when I discuss the roots after making this point. What is the best way to solve? Again, stick to the do's of algebra. Take things to the left-hand side. Factorize by identifying certain patterns. This is in the form of x square minus 5 square. That's a square minus b square. That's x minus 5 into x plus 5 is equal to 0. So x is equal to 5 or x is equal to minus 5. These would be the solutions to your equation. Avoid taking square roots on both sides. Now, obviously, the question most of you all will have will be, but Aditya, it's giving me the same, taking square root on both sides gives me the same answer. What was wrong? Root of x square is x, root of 25 is plus or minus 5. I'm getting the same solutions. Why are you telling me not to take the square root? So let's understand the square root a bit, okay? So avoid taking square roots on both sides. So instead, what is the best thing to do? Follow the do's. Don't cancel variables. Don't take square roots. Pull terms to one side. Keep the right-hand side 0. Factorize the left-hand side into a product or division of values. Now coming to that million-dollar question, why can't you square both sides? For this, you'll need to understand what a square root and what an absolute value is. In my past 8 years or 9 years that I've been taking personal tutoring, I see a lot of test takers making this mistake. They don't have a rudimentary or a fundamental understanding of what the square root and the absolute value are, right? So I'm going to explain that to you. The square root and the absolute value. I'm not going to go in depth, especially with the absolute value at this point. I told you there's going to be a specific session that is going to deal with the absolute value, but I'm going to give you an initial understanding of the two. And I'm going to make some extra points as well, which are crucial towards understanding algebra. So the square root, represented by that symbol, and the absolute value, represented by this symbol, they are what we call functions. This is the absolute value function. That is the square root, or also called the principal root function. Now, if you'll have prepared for the test before, or you'll have prepared for the algebra topic, I'm sure you would come across the topic of functions, right? Now, if I ask you what a function is, normally everybody would explain it's f of x or g of x. No, that's not a way to understand functions. Any function would always have three parts to it. The first part, it would have a fixed definition. If you're interested to know, any equation that you have in algebra is a function. The equation y is equal to x square plus 4 is a function, right? Why? Because I'm defining what y is. Y is equal to x square plus 4. Most of you all here in the webinar, I'm 100% sure, would use Excel sheets. And I'm sure you use functions in Excel sheets, right? At least the average function. So when you pick the average function, you know exactly what it's going to do. It's going to pick all the data from all the blocks that you select. It's going to add them up, and it's going to divide by the number of elements that you've picked, number of blocks that you've picked. So any function is always going to have a fixed definition. And any function is always going to have an input or some inputs. And based on that input, it's going to give me some output. Here, what I put in for x is the input. What I get for y is the output. Any algebraic equation is always a function. Functions can also be symbols, and the square root and the absolute value are symbolic functions, right? So any function should have a fixed definition. So let's define what the square root is first. What is the fixed definition of the square root? It is a function that churns out an output that is 0 or positive. Whatever comes out of the square root will always be 0 or positive. You can't have a negative quantity coming out of a square root. That's the definition of it. The square root is a function. The principal root is a function that churns out an output that is 0 or positive, and also divides the power by 2. Obviously, it's to the power of half. This is the exact definition of the square root. It can take whatever I want as inputs. We don't put a negative input on the GMAT because we don't deal with imaginary numbers. But whatever you give as the input to a square root, the output will always be 0 or positive. If you give negative inputs, we get imaginary outputs. Let's not touch on that at this point. But the square root will always give an output that is 0 or positive. So will the absolute value as well. The absolute value does exactly what the square root does, but it does not divide the power by 2. It's a function that always churns out an output that is 0 or positive. I want you to understand these definitions, please. Okay. Like I said, a function always has a fixed definition. This is the fixed definition of the principal root function and the absolute value function. And like I said, based on its definition, the function can have inputs, and based on its inputs, it will give you outputs. Now, inputs to functions can be in one of two ways. You can have an input to be a constant value. A constant is a fixed value, something like 25, or something, if I put in an absolute value, minus 25. And when I input a fixed constant into the function, all I'm worried about, since the input is fixed, I'm worried about what it will churn out as an output. And I told you the principal root will always churn out an output that is 0 or positive. So root of 25 will be plus 5. Root of a constant is not plus or minus. Root of any constant is positive or 0 if 0 is the input to that function. And the absolute value of minus 25, like I said, I'm inputting a constant here, so I'm only worried about my output. The output is going to be 25. Right? I want you to understand this, guys. Right? The root of any constant is always positive. The absolute value of any constant is always positive. Why? Because constants are fixed inputs. If they are fixed inputs, I need to only focus on the output. And the output I know based on the definition of the functions is always going to be 0 or positive. So if someone asks me what is the root of 36, I would just say plus 6. Root of 49 is plus 7. The absolute value of 25 is 25. So root of any constant is always 0 or positive. Absolute value of a constant is always 0 or positive. Now, when do we get the negative bit? Somebody's already put that question here. Guys, I will cater to all questions, so hold off from the questions, because high chance I will cater to everything. If I still don't cater to it, I will give you some time towards the end to ask me those questions again. Now, what if I told you, right, we have inputs to any functions, and those inputs give me specific outputs. We saw what happens when the input is a constant. But what if I have an input to be a variable? Now, a variable, like the name suggests, variable is not a fixed input, right? That variable can either take a plus value or a minus value. So if someone gives me what is root of x square, right? I'm using x square because, of the question I gave you, x square is equal to 25. Let's say the absolute value of x. Let's say the inputs, we need to find out what is the root of x square. We need to find out what is the absolute value of x. So remember, the input here is what we put in for x. The input here is also what we put in for x. And since x is a variable, right, it can take both positive as well as negative values. And think about it, right? It's very simple to understand this. When we had an equation, x square is equal to 25. If we want to analyze this equation, this is also a function. Any equation on algebra is a function. This is also a function. But in this function, when I have a variable that is associated, the entire focus on that equation is to try to solve for the variable, right? You want to solve for x. So here, we are never worried about what the output of the equation is. The output can be anything I want. I'm not worried about the output. I'm worried about what values can I substitute for x that gives me that output. And the values I can put in are plus 5 and minus 5. Right? And that is what we get when we pull things to the left-hand side and factorize. So here as well, when I have root of x square, I know the output of that is always going to be 0 or positive. But my focus is on what can be the solutions to this equation. What can be the inputs here that gives me that 0 or positive output. And the inputs here can either be a plus x or a minus x, because a root of plus x the whole square is still the same as root of x square. And root of minus x the whole square is still the same as root of x square. Similarly, the absolute value of x, what comes outside, will always be 0 or positive. But I'm not worried about the output. I'm worried about the solutions, the input to this. And this would be a plus x or a minus x, because the absolute value of plus x will be the same as the absolute value of x. And the absolute value of minus x will also be the same as the absolute value of x. Right? Simple way to understand this is, when I have the absolute value of x is equal to 5, we are not worried about the 5 here. We are worried about what values can I substitute for x that gives me the 5. And that would be either a plus 5 or a minus 5. So a plus x and a minus x. So in simpler terms, the root of any variable square will always be plus or minus the variable. Why? Because our entire focus, when we have the function that applies to a variable, is that we focus our attention to what the solutions to that equation is, the inputs to that equation. Right? So root of any variable square is always plus or minus the variable. And same with the absolute value. The absolute value of any variable is always plus or minus the variable. If you want me to actually define the functions, you want the actual definitions, I'm going to write down the actual definitions for you. I told you any function is always defined. So what is the function root of x square defined as? Let's see. Let me just clear my screen here. Okay. So root of x square is defined as plus x when x is greater than or equal to 0. This is the exact definition of the function on root of x square, right? Function of root of x square. It's plus x when x is greater than or equal to 0, and minus x when x is less than 0. And that's the same as the absolute value as well. The absolute value of x is plus x when x is greater than or equal to 0 and minus x when x is less than 0. Because anytime a function applies to a variable, your entire focus needs to shift on what the solutions to that equation is, what the inputs to that equation is, not what the output is. But for any constant, since the inputs are fixed, you're only worried about what the output is, right? So what I want you to hold on to is this. Simple way to understand it is whenever you're taking the square root of an even powered term, you have to consider the plus and minus possibilities. If you're taking the absolute value on any variable term, you have to consider the plus and minus possibility. So if someone asks me, Aditya, what is root of y to the power of 4? So I will say, okay, I'm taking the square root on an even powered term. So this would be plus or minus y squared. What is the fourth root of y to the power of 4? Again, I'm taking the root of an even powered term. That would be plus or minus y. But taking an odd power doesn't require you to flip between the plus and minus possibilities, because the odd power will always take the same sign it comes with. For example, if I give you x square is equal to 4, you will tell me x is plus or minus 2, not by squaring both sides, by looking at x and saying what can I substitute for x that gives me the 4, or by pulling the 4 on the left hand side and factorizing it out. But if I give you x cube is equal to 8, you will not tell me x takes a plus 2 and a minus 2. You'll only tell me x takes a plus 2. Because only a 2 cube can give you a positive 8. So when you take the root of an odd powered term, I don't need to worry about the plus and minus possibilities, right? So if someone asks me what is the cube root of y cube, I would just say y. It will take the sign of what it comes with. If somebody says what is the fifth root of y to the power of 5, again, I'll just say y. Why are we taking equal to? Why are we not taking equal to with less than? Because we've already taken the equal to sign with x greater than or equal to 0 alak. Okay, you can take the equal to sign either with the less than or with the greater than. It doesn't matter, because when x is equal to 0, everything will be 0, right? So I have to cater to 0 somewhere. So I've catered to 0 and the x is greater than or equal to 0. You can also, if you don't want to put it there, call it x greater than 0 and say x is less than or equal to 0. No problem. Okay. Or you want to write it separately, root of x square is equal to plus x when x is greater than 0, minus x when x is less than 0, and 0 when x is equal to 0. That is also absolutely fine. Got it? So guys, in a nutshell, root of any constant is always 0 or positive. Absolute value of any constant, always 0 or positive. The square root of any variable square is plus or minus a variable. And the absolute value of a variable is plus or minus a variable. If you want to know the exact definitions of the square root of x square and the absolute value of x, I've written it here. This will be very important for you all to understand going forward. Because I told you the biggest problem with square roots and absolute values is people don't understand its definition in the first place. They don't understand that they are functions in the first place. And functions have to have a fixed definition. All right. And also what I want you to remember is whenever you're taking the square root or when you're taking any root of an even powered term, remember even powered terms can always take both the plus and minus possibility. So you have to take that into consideration. But when you're taking an odd powered term, you don't need to worry about the plus and minus possibilities. Odd powers always take the same sign as what they come with. All right. Okay with this, all of y'all? Any doubt on this? I'm just giving you an explanation here. It's very, very important for you to hold on to this because many test takers make a mistake here, right? So what would have been correct for you to do if you had x square is equal to 25? If you're taking the square root, I would not suggest you do it. But if you're taking the square root on both sides, you have to compensate for taking the square root by taking the plus and minus possibility. So you'll say root of x square is plus or minus x, and root of 25 is 5. And then you can say x is 5 or x is minus 5. This is acceptable. But like I said, stick to the basic 101s. Take what is the right hand side to the left hand side. Sorry, why is it minus x when x is less than 0 for the square root case? Think about it, right? If I have root of x square, right, I can either put x as a plus 5 or I can put x as a minus 5, David, right? Because anyway, it's going to get squared, right? So the entire term, what I'm going to be left is a positive value, no? So root of x square, I can either put x as a plus 5 or a minus 5. Suppose I say root of x square is equal to, um, say, 5, or let's say, right? So I will ask myself, right, what values can I put in here for x that will give me that 5 as an output? Or I can square both sides. That's also possible for me to work, right? I can square. Ideally, the best way to work is to square both sides. But if you want to look at it as solutions, what values can I put in for x that when squared and then you take the square root gives you 5 as the output? I can put in a plus 5 because root of plus 5 square is root of 25, which is still 5. Or I can put a minus 5 square. Minus 5 square is still a 25, and that will still give me a 5. Right? That is the definition of the function. We are looking at what are the inputs to that equation. Right? So if you take it and square both sides and solve for it, you will still get x is equal to plus or minus 5. Got it? I'm hoping all of you are with me here. I'm not trying to go into too many questions from the outset. I'm trying to build the foundations that are required for us to solve the questions that I'm going to bring in. Okay. So I'm touching upon problem areas that I think most test takers will have because their understanding of that concept is not up to the mark. So I'm putting certain guidelines and I'm also telling you why certain things you learned is wrong and I'm correcting it as well. All of you all with me to this point? Yes? Any doubts so far? I'm hoping all of you are understanding my handwriting. I know it's very cursive in nature. So, all right. So, nobody said anything about it yet. So, I'm hoping you'll have understood what I said. Right? All right. So, let's then look at the first question. Yeah, the question that I have. I'm moving on to the slide. Guys, can all of you all see my slide on the screen? I think you can. I will share the slide. I will ask the admin to send you a PDF copy of the slide, okay, of all the slides with the questions as well. So that will help you for reference as well. Okay, so I've listed out whatever I've written here, right? So you can use this as a reference, take a printout and keep it, right? Same thing here as well. Whatever we've discussed, I've listed out for you to refer. And here's your first question, okay? So whatever we've done so far in the past, say R, right? Comes down to this. I'm going to start with slightly easy level questions. We're going to discuss them. We're going to link it to what concepts we've learned, and then we move forward. Okay, so I'm going to give you all of you all, say, a minute and a half to solve this because it requires that much time, and then we'll have a discussion. Okay, do not put in the answer choices in the chat window until I say so. Your time starts now. Okay, you can start putting the answers in the chat window. Mohammed, which last point do you want me to repeat? Can you specifically say that, please? Okay, I see five of you all have given me an answer. We have around 75 people here, so I'm still expecting some more answers. Guys, if you've got stuck at a point, absolutely fine for you to say, I'm stuck. Okay, so let's discuss this. Right, I see most of you all, I think around 10 to 11 of you all have given me an answer, and that's the right answer. Rishabh comes up with not the right answer. So let's discuss, okay? And I'm going to link this to what we spoke about in the last hour of a discussion, right? The first thing I said whenever you work with an algebra question is take a step back, observe what you have. I want all of you all to try to start doing this. Observe what you have. They've given me x is not equal to minus 3. Now, when I work with an algebra question, right, I always ask myself, why have they given me these constraints? Why have they given me x is not equal to minus 3? Because they've given me the x plus 3 term in the denominator. You see, I have x plus 4 divided by x plus 3 is equal to x plus 1, right? So whenever I have a term like this in the denominator, I cannot divide things by 0, right? So they've given me x is not equal to minus 3. That's the purpose of this. And I have such an equation here. Ideally, when I have such an equation, I would want to simplify this to make it, into a product of values. I would want to, simplify it and solve for the variable that I have, right? So obviously, most of you all would have done this. You'll have multiplied both sides by x plus 3. It's absolutely okay to multiply both sides by x plus 3 because I know that x plus 3 is not equal to 0. So I'm going to write x plus 4 is equal to x plus 1 times x plus 3. Most of y'all here would have done this for sure. X plus 4, then you would have opened this up, and that's x square plus 3x plus 1x plus 3. And then you would have taken everything to one side. I'll take the x plus 4 onto the right hand side. So x square plus 4x minus x is 3x. 3 minus 4 is minus 1 is equal to 0. This is what you would get. And now what happened? For those who didn't give me an answer, you all would have got stuck here because you'd got a quadratic equation that you would not be able to factorize very easily. Some people would dive right in and go into b square minus 4ac, the quadratic formula. But I told you, what is the most important bit after you break down the question, after you simplify? Always focus on what the question is asking. Your manipulations of equations should always be based on the question. Right? Do not get into solving. I don't need to solve for x here. I need to solve for x square plus 3x plus 1. And this is where observation is going to help you out. The most important word, observation. From what I have, how do I get to what I want? I have x square plus 3x, which is similar to the first two terms here, minus 1, but I want a plus 1. So what I can do is I can just add 2 on both sides. Absolutely fair for me to do it on both sides without changing the value of the equation. So this would be x square plus 3x plus 1 is equal to 2. That would be my answer. That is one way to look at it. The other way to look at it is when you got x square plus 3x minus 1 is equal to 0. Again, look at what the question is asking you to solve. I see that x square plus 3x is the common terms from what I have and what I want. So I will isolate that x square plus 3x is equal to 1. And since I know x squared plus 3x is equal to 1, I can take this 1 and I can substitute it for x squared plus 3x. So 1 plus 1 is equal to 2. Answer is C. Got it? All of y'all? It's very important. It's very important for you when you work with algebra-based questions, even the simpler ones, to take a step back, observe what you have, simplify, break things down to the lowest form, sticking to those guidelines that we've discussed. And what is the last guideline that I said? A very important guideline. Work towards what the question is asking you, right? So the question here was asking me, what is the value of x squared plus 3x plus 1? Got it? You can also do that as well, David, but think about it. No, I mean, David, if I move it to the left-hand side, the amount of working that I will have to do is going to be a lot more than just cross multiplying and working. Makes sense? That is why I did not do that, right? I quickly could cross multiply because it's an equality, and they've also given me a condition that x is not equal to minus 3. That's a good question. David said you can also, pull things to the left-hand side and work. I absolutely agree, right? Keeping the right hand side 0, left hand side as a product or division of values is good. But then again, I have to take the LCM here and I have to simplify, get the numerator, get the denominator. Cross multiplying would just give me everything in a linear form, right? And getting rid of the denominator is what I want, right? I'll get everything in one line, and then it becomes easy for me to get to the answer in a couple of steps. David, absolutely fine. Okay, let's make it a little harder. Okay, I started with a very base level question, right? So you see the point I'm making, how well designed a GMAT question is going to look like, right? It's not only going to test you on how you break down the math, it's going to test you on how you use the information that you have to your advantage. Observation, reasoning, and in-depth understanding, and understanding certain guidelines. These are what are important. Focusing on the question. All right, let's take the next question. Again, give it a shot. Stick to the straight and narrow. What are the guidelines we worked with? Stick to the do's and don'ts. You will get your answer very quickly. And I'm expecting more than 10 to 12 people answering. 77 people are here. I would expect at least half the people to get to an answer to this. Try it out, please. A minute and a half again. For those who've got your answer, right, I would want you to think of what could be the common pitfalls or the common traps that test takers might fall for here. Okay, think about it and think about what could be a mistake and why would the answer choices become problematic for that, right? Remember, my funda is always towards not solving a question, but to look at different ways you can pull out information from a question, right? You can learn from questions very well. So think about those getting the answer very quickly. Think about what mistake you think the test takers can make, on this question, right? And then think, if you make that mistake, what happens with your solutions? Yes. So I see most of you all have given me an answer. If you stick to the straight and narrow, work with the guidelines, you will get to an answer very quickly. Like I said, whenever you see an equation, the safest thing to do, you can definitely open it up. I would open this up because I can cancel out xy on both sides. I can subtract xy on both sides. But then when I get z is equal to xz, I should not cancel z on both sides, because if I do, I would get x is equal to 1, and then I'll be left in a big problem. Why? Because I have three answer choices that give me x is equal to 1. Right? So the safest thing to do, pull things to one side, keep the right hand side 0, take z common, 1 minus x is equal to 0, z is equal to 0, or x is equal to 1. That would be the solutions to that equation. So in 30 seconds, I can get to my answer rather than overcomplicating the algebra. All right. Another way you could have solved it, it's a must be true question. So obviously you can go the route of disproving, but this is what I normally do, right? When I see a must be true question, I will cater to it a little more in the inequalities discussion. But when I see a must be true question, my first instinct is to always try to prove it algebraically, right? If I'm able to break down and work with it algebraically, it's the easiest process for me to employ. But another way, if I'm not able to break it down algebraically, then I would think about disproving. It's not a very difficult question, so the algebra bit directly works out, right? Okay, let's take it a notch further. An official question from the official guide, right? Give it a shot, please, right? That equation, guys, is ax into cx plus d is equal to minus b into cx plus d, right? The minus and the b are split on each line. Just ensure that you consider that. Atul, xz minus z would not be right, no? Then if you, if you, let's discuss this after this question, okay? I think you need to group your terms a little better. So you can do z minus xz is equal to 0 or xz minus z is equal to 0, right? If you take z common, it would still give you the same output, no? Z is equal to 0 or x is equal to 1. Why don't you continue from doing that? I mean, I just did it by pulling the xz to the left hand side. You took the z to the right hand side. It's exactly the same. If you continue working with it, you'll still get the same output, okay? Yes, Sahej, we're canceling variables on both sides is a complete no-no. It will be more of a problem when you go with inequalities as well. Okay. Okay, I see that answers are already coming in. Okay, I do have kind of a mixed bag. So, like I said, I'm making the questions slightly more and more difficult. So, obviously, you know, mistakes will be prevalent. Okay. Pratik, you're giving me an answer which is not there in the answer choices. Okay. All right. Okay. Last 20 seconds. Okay, Pratik. Last 20 seconds and then we'll discuss. Again, guys, stick to what the guidelines told you. For people who dived right in and opened the brackets, and are wondering what to do after that, that's a recipe for disaster. Remember what I said. Don't get into opening brackets and everything from the outset. Study the equation that you have. Understand the question. That's more important. On harder levels of questions, you need to get a good understanding of the question as well. Then execute. Okay. So let's break this question down. All right. Let A, B, C, and D be non-zero real numbers. Basically, it can be any number under the sun on the GMAT except for 0. And they tell me if the quadratic equation AX into CX plus D is equal to minus B into CX plus D is solved for X. So I'll stop there. They're asking me to solve this equation and they're asking me to solve for X. And looking at this, if I observe this equation carefully, I know if I open the bracket, I'm going to get an x squared term on the left-hand side. So it's obviously a quadratic. But remember, they're asking me to solve. And when I solve a quadratic equation, the entire focus has to be on trying to factorize things, pull things out common, maintain things in terms of products. It wouldn't make sense for me to open the brackets and be left with an addition, of terms that are with 4 different variables. Correct? So again, follow the simple rules. Instead of opening things up, keep the right-hand side 0. The general form of a quadratic equation, for those who know about a quadratic also, is ax square plus bx plus c is equal to 0. That is how you represent a quadratic in its general form. Here, and then you break down this into a product, right? Like x minus a into x minus b is equal to 0. So when you're breaking a quadratic equation into, factorizing it into a product, why wouldn't you want to do it here? So plus b into cx plus d is equal to 0. I'm keeping my right hand side 0. And immediately if I notice on the left hand side, I have cx plus d common. So cx plus d into ax plus b is equal to 0. And they're asking me to solve for x. See, I'm focusing on my question. I'm working towards my question. It's solved for x. So either cx plus d is equal to 0 or ax plus b is equal to 0. So x is equal to minus d by c or x is equal to minus b by a. I want you all to observe one thing. Whenever I'm working with quadratic, you see, I'm using the word or between the solutions. I'm not using the word and. Because when I say the roots of an equation is 2, it's not and 3. The roots of the equations are 2 or 3. So here x is equal to minus d by c or x is equal to minus b by a. It's solved for x. I've solved for x. Which of the following is a possible ratio of the 2 solutions? I should ask myself, why are they saying possible ratio? Because if I want a ratio of the 2 solutions, a ratio can be the first term divided by the second, or it can be the second divided by the first. I need to do both. So minus d by c divided by minus b by a, or minus d by c, or minus this, or the reverse, minus b by a divided by minus d by c. Minus d by c into a by minus b, that would give me ad, the negatives would go, by bc, or this would give me minus b by a into c by minus d, that will give me bc by ad. But the question is asking me which of the following is a possible ratio. So these are the 2 possibilities. The answer choices only give me one. I pick E as my answer. Got it. So I have to solve for x, Syed, right? And that's why I said, right, when you work with an algebra question, you get so caught up in the equations that you have that you will forget to read the question. What did I do? I underlined that it's solved for x. So once I get that, I need to make x the subject of the equation. For those of you all who got stuck at the same point as Syed, you all didn't read the question carefully. You all didn't follow the instructions. All right. And some of you all I see gave me a different answer because you all messed up the signs, right? So you all gave me minus AD by BC. You all didn't cancel out the negatives. So that was more of a silly mistake that you need to avoid. All right. So see, again, I'm sticking to the guidelines that I've put in, right? I'm not deviating from it. Keeping the right hand side 0, the left hand side is a product or a division of values. break down the question, focus on what the question's asking, solve towards the question. It's not a very difficult question, Alak. I would say, yes, it may be a medium difficulty. I know it's classified as a little more difficulty question, but if you ask me what you get with the actual GMAT, um, you know, there are harder questions than this as well. Okay. Questions on the GMAT, to be fair, are never hard. Okay. They are tricky and they'll expect you to think in different ways at some points. Okay. So that's what we're trying to do. We're trying to figure out what are the different ways of approaching questions. Got it? All right. So I want to make a special point with this question. I want all of you all to give it a shot again. I think it warrants only a minute and a half. So I'll give you that minute and a half, solve it, and then we'll discuss and then we'll work. Come up with a difficult question. It's coming, Manav. It doesn't make sense for me to pick a difficult one from the outset, right? So guys, for anyone who's confused, the square root applies to the entire first term, 3 minus 2x. The square root applies to only 2x, right? That's the equation. Okay, so just don't make a mistake copying it down. No, Sasha, I just cater to that, right? It's the root is only on the 2x. That's why the brackets, the 2x is bracketed. I'm hoping, Manav, this is difficult for you. Then let's see. I will go into a more difficult one after this as well, but I already see different answers. Okay, Rhythm, so you've changed your answer. Okay, David says D. Alak is E. I thought the right answer is completely under the square. Fair enough. Look at the question carefully, all right? Always look at the question. Remember, the root is on the 2x, right? So I've written it. I expected most of you all to look at it and quickly take the root in the entire term. So I rewrote it on the right-hand side. Okay. Okay, last 20 seconds. Stuck. All right. Okay, guys. I'm slowly moving ahead in terms of difficulty. It's absolutely fine if you didn't get it right, right? Remember, it's all about learning from the questions that you have. Okay, I wanted to make a point with this question. That is why I've picked this. I also, have seen a lot of questions that deal with square roots on the test as well. Now, See, when we spoke about square roots, right, I said that when you have an equation x square is equal to 25, I said that it's better always, the better guideline to follow is to avoid taking square roots on both sides, because square roots always come with a level of complexity that you don't want. So when you're avoiding going to take square roots when you're working with a question, when you have an equation with the square root involved, you would always want to get rid of the square root. So whenever you see questions, right, that deal with square roots, your first instinct should always be to get rid of the square roots. And how can you do that? You can do it in one of two ways. You can square both sides, totally legitimate for me to do this, or you can also break down things by using the definition of root of x square. If you have something root of any squared term, you can use the definition to break it down. Remember, the root of x square is plus x when x is greater than or equal to 0, and minus x when x is less than 0. And another thing that I want you to hold on to is, remember, your focus always is to try to get rid of the square root, right? So whenever you're working with things, try to isolate the root term. If you have multiple root terms, it's fine. You don't need to do that. But if you have a single root term in an equation, learn to isolate the root. So the first thing I would do is I would square both sides here. And you see how I'm writing this. One mistake that people would have made would be not to take the whole square term on the right hand side, right? They would just open it up as 2x plus 1 rather than opening it up as a plus b whole square, right? So that basically tells you that I need to look at my question carefully. I need to do the step of putting the square terms on both sides. Now, root of 3 minus 2x square would be 3 minus 2x. And this is in the form of a plus b the whole square. So that's a square plus b square plus 2ab. That's 2 into 1 is 2. Into root 2x will be 2 root 2x. And now I can simplify this, right? I can simplify it further. I still am left with the root. So again, my focus has to be on, I want to get rid of the roots. So I'm going to take all of these two terms on the left hand side. I want to isolate the root, because if I don't isolate the root and I still square it, I'm going to be left with another a plus b whole square, which will again give me another root, and I don't want it. I want to get rid of the roots. That's the entire goal of my manipulation. So I'm going to pull these two terms to the left hand side. So 3 minus 2x minus 2x minus 1 is equal to 2 into root 2x. So that's 2 minus 4x is equal to 2 root 2x. I told you simplify it to the lowest form. I can pull out 2 common, so that's 1 minus 2x is equal to root 2x. Again, I want to get rid of the square. So I want to get rid of the square root. So I'm going to square both sides. You see, isolating the square root eliminates the square root entirely for me, right? So I'm going to open this up. 1 plus 4x square minus 4x. Be careful with the a plus b whole square is equal to root 2x whole square would be 2x. Now, when I have this equation, look at what the question is asking you. Don't forget to focus on the question. The question is asking me for 4x square. Focus on what the question is asking. So 4x square would be 2x plus 4x. I'm taking the minus 4x to the right hand side. Minus 1. So 4x square would be 6x minus 1. That is my answer. Got it? So your biggest takeaway is this, that whenever you see a square root in an algebraic equation, it's not your friend. Get rid of it. How can you get rid of it? You can square both sides, or you can use the definition of root of x square to break it down. But when you're getting rid of the square roots, try to be smart about the equation. Try to isolate the square root on one side, because if you don't isolate the square root, you leave it attached to another variable, another equation, another variable, or another constant, then you'll have to use the a plus b whole square formula. Correct? All of y'all? Any doubts on this? Okay. All right. So let's make it a little harder. Give it a shot, please. Now, this is hard, okay? Let me see how many of you all work with this. I'll give you all a good part of 2 minutes to break this question down, and then we'll move forward to linear equations. I'll give you a break after this, and then we'll move forward to linear equations. Give it a shot, please. Okay, you can start putting in your answers in the chat window. Yes, Pratik. So that's a good way to think as well. Okay, that's another reason why I've given you this question, right? Because there's two ways to look at it, and I want to add that point as well. So for those who've got your answer and you'll used your answer choices to work with it, why don't you all explore the algebraic solution to it, right? That's what I would advise. There is a negative on the right hand side. Okay, for those who got E as the answer, can all of you all put in your processor working as well, please, in the chat window? Shweta, it's a mix of OG questions and also questions that I've pulled from GMAT Club as well, right? If I pick OG questions, then most of you all will tell me OG questions are very easy. So I'm trying to keep a mixed bag. It required 2 steps of squaring, says Sumam. Okay. What about the others? Kusha, Rhythm, how did you try it out? Did it algebraically? Moved square roots? So, okay. Root A, root C, root B. Square it. Very good. Isolated the root. Very good. Solving it was a bit difficult, so pick some values. Very good, Manav. Absolutely good. Right. So in your case, I would still, you know, look at it more from a data sufficiency point of view. What if you get a data sufficiency equation like this? How would you simplify it? Would you don't have answer choices to work with, right? So I would still explore the algebra process, right? Okay. Foil the initial with a square. Perfect. That's also right. Okay, I see most of you all have employed this. You all said root of A plus root of C is equal to root of B. And then you all squared both sides, correct? Okay, so let's work with it. So this is smart, right? I wouldn't want to square. Remember, try to use the algebraical identities that you know. What do you know is A plus B the whole square. You're very clear about it. I don't want A minus B plus C the whole square to work with, right? I can do it if I remember the formula, but it's better for me to try to put my equation into something that I recognize, right? So I'll pull the root B onto the right hand side. I'll square both sides. So this would be A plus C plus 2 root AC is equal to B. Now, what did you all do from this point for those who work with here? Now, at this point, what did you all do? I'm assuming most of you all did this process. Anybody can quickly type in the chat window. What did you do from here? You isolated the root. So A plus C minus B is equal to minus 2 root AC. And then you squared both sides again, right? So I square both sides. And this is where your A plus B plus C whole square will help you out, right? So A square plus B square plus C square plus 2AC minus 2AB minus 2BC is equal to 4AC. So for someone who mentioned that I have a negative sign, guys, you must have not done the minus 2 whole square, right? You would have left it as 2 itself, right? So now I look at the answer choices, right? And I see it's A square plus B square plus C square prevalent on the left hand side. So I'll work towards what my answer choices give me. I'll take everything to the right. So that's 2AB plus 2BC. And 2AC minus 2AC becomes minus 2AC on the right hand side. That's plus 2AC. Right? So clearly E holds good. So the algebra approach is actually relatively straightforward here. Right? Yes, you can look at A plus C as one unit alike as well, right? So the algebra approach was just 3-4 steps that you had to work. But I like the fact that most of you looked at the question more from a solving perspective. Yes, you have to do that on test day. On test day, if you're given a question, you're getting stuck, you should think about solving it and moving forward. But if you're learning, right, I would recommend for you to look at what the algebra process would be and try to build on your algebra skill sets on data sufficiency questions. When you have to work with algebra, you're not going to be given answer choices to work with, right? So this is the conventional process. Not too bad to work with this. But some of you all did this, and this is a very good takeaway. I mentioned this as well in the quiz that we had on inequalities and absolute values. Whenever you see a question in algebra, not only in algebra, even when you have word problems, and you see that your answer choices right, are variables. You have variables in the answer choices. These questions always provide you an opportunity for putting in values and running your way through the answer choices, right? But like I said, you have to be smart about the values you choose. They've told me that A, B, and C are positive, real numbers. I need to respect this constraint. And they've given me root of A minus root of B plus root of C is equal to 0. So I need to assume values for A, B, and C that satisfies this equation, right? So what values did some of you all take to work with this? I would take anybody. What values did you choose? I can use yours or I'll pick the values that I want. I want to pick values which obviously are going to be perfect squares. And when you take the square root of them, it adds up to a 0, right? So 4, 1, and 1. So you took A is 4, B is 1, and C is 1. Slightly risky to do this, right? But let's run with this, right? Let's run with this. So A is 4, B is 1, C is 1 would give me root 4, which is 2, minus 1 plus 1. But root 4, 1, and 1 is not going to add up to 0, right? That's not going to work. Yes. So what else? A is equal to 1, B is equal to 4, and C is equal to 1. Perfect. So that's 1 minus 2 plus 1, which would give me 0. So these are values that would satisfy the equation, right? So if you're using this process of working, you have to pick values for the variables that satisfy the limitation that is given. And then you need to take those values and run through your answer choices, right? So A square minus B square. So since you have A square, B square, and C square, you can easily work. A square would be 1 minus 16 plus 1, which is clearly not 0. A square is 1 minus 16 plus 1 will be equal to A minus B plus C. That's 1 minus 4 plus 1, which is not going to be equal to each other. Obviously, looking at this, right, A square plus B square plus C square is going to be way bigger than A plus B plus C, so I would not bother with it. D and E seem to be legitimate, possibilities, right? So I would say 1 plus 16 plus 1. So I'm going to get 18 on the left hand side, but AB would be 4, BC would be 4, AC would be 1. That's giving me 9. Here I've got 18. So clearly you know that the left hand side is double the right hand side, right? It has to be echo. Okay. I would always prefer the algebra approach, Alak. I always use this as an alternate to the algebra. If the algebra fails me, immediately I would make the switch and I would put in like some values and run my way through the answer choices. The way the question is designed gives you that opportunity to do so. Okay, you have that option as an alternate, but you see, I had to pick the right values. I have to ensure that the conditions are satisfied, and then the worst bit is running through the 5 answer choices. And what they would do normally on test days, they'll give you the answer choice as maybe an E or a D, right? Where they'll make you run through the answer choices. Now people will say, let me go backwards. I don't know. It may be A as well. Got it? It's a good alternate to have. Okay, it's a good alternate to have. May not be the first approach that I work, but if nothing strikes you, right, remember, it's always good for you to use that process, get to an answer. You're not going to be given brownie points on how nicely, intricately you work the question, right? You're going to be given a point for getting that question right or not, right? You can't bypass the algebra approach, Paul, right? If you try to bypass algebra, right, you can do it for the lower levels of questions. You cannot do it for the higher levels of questions, right? As you go forward, you'll see with inequalities and absolute values specifically, right? When you have an inequality involved, picking values is not a very good proposition for you, all right? Okay, so I have another question, but let's skip over that. You can try that out maybe when you get the PDF of this slide. Do you do you guys want a break of maybe a couple of minutes and then continue? Because like I said, it's going to be a long session. I have another part to discuss. My sessions are always long and grueling, but there will always be some takeaways from it. So if you want a break, let me know. If not, we can continue. Okay. Nobody's asking for a break. 2 minutes. What was the initial clue to take B on the right hand side? Yeah, okay. So that's a good question. The initial clue to take B on the right hand side was I did not want to square it and have A plus B plus C whole square, right? I would want to try to use something that I identify with a lot more. And since B is a negative value, right, I would want to another, thing that I would want to do is make that positive as well, right? That's why I took the B specifically onto the right because it had a negative sign on it. Okay, for you can just take a 2 minute break, guys. For those who are still here, you have any doubts, I can quickly cater to those doubts while the others are taking the 2 minute break as well. Okay, you can take a 3 minute break, Shweta. I will wait, right? I know it's hard. It's already 11, so most of you all have come back from a hard day's work. I am also at the end of a hard day's work as well. So I'm ready to, maybe I need another hour or so. So guys, just be ready to burn the midnight oil with me, right? So we may go on till maybe 11:45 today. Okay. If you want to, I'm giving you a heads up now itself. I see that the numbers are increasing rather than decreasing, but thank you for staying up so far as well. Okay, Paul. Depends, Paul, because I think I chose topics that I feel test takers normally would have problems with. There was also a clamor for sessions for probability and permutations and combinations. So I ended up picking those. I also picked data sufficiency as well, if time permits. Right then, let me see. I'll speak to the admin. Maybe an arithmetic session will do as well. Okay. You guys have been great so far. Okay. Uh, Good discussions coming up in the next, say, 45 minutes. I'm going to speak about linear simultaneous quadratics, give you certain guidelines. And the guidelines that I give you for them will also be very, very, very crucial and useful on data sufficiency questions. I do have a couple of data sufficiency examples as well, and two-part analysis questions on the DI section. Okay, so I don't have a two-part analysis question here. That would be too long for us to work with. I'm already running beyond time. So for people who don't know what a data sufficiency is, guys, just let me know in the chat window if you're new to a data sufficiency. For those who know what a data sufficiency is, I think there's one or two questions. A minus B plus C the whole square, right? So this is in that form, no? This is like an A, right? Root of A is like an A. This is like a B, and this is like a C, right? So A minus B plus C the whole square. If I know what this is, I can do it. But the problem is, right, this becomes little, say, um, ugly in terms of calculations, right? It's better for me to take the B and work my way through by getting rid of most of the square roots first. Guys, for those who wanted the 2 minute break, go ahead. For those who are staying back, you can ask me questions by the time they come. I'm going to wait for exactly another 2 minutes before we start. Okay. Uh, Abu, weighted averages, I think, is better dealt with in a statistical setup, uh, especially when you're working with averages. Not only averages, mixtures questions, and you know, um, say percentages questions, right? And maybe speed, distance, time as well, because you deal with average speed. What I can recommend, Abu, is I think there should be some video of mine done long back about remainders. Okay, this was with my time, at a different test prep company. I did a session on remainders. So you can just type in the remainders, Aditya Kumar, GMAT, and I think you'll be able to work with it. Remainders is one, and I've also done one with allegations and weighted averages. That is another. Okay. One more minute, guys, and then we'll start. Okay, I guess everybody's able to see my sketchbook, right? How much role does luck have to play? Shweta, if your score is in the low 70s or 80s, right? There are certain areas that you'll need to work on. So the first thing you'll have to identify is what specific areas you have a problem with. Is it timing? Is it conceptual gaps? You need to need to fix that, right? And once that is fixed, right, and you consistently score something like 82, 83, 84, then you can think of optimizing further, right? How much role does luck have to play? It does play a role, Pratik, because you may end up making a silly mistake, but you may end up still getting a 90 because the mistake that you made was a harder level of question. You may end up with one mistake and get to an 87 as well. Okay, so it depends upon the difficulty levels. If you want to get a 90 guaranteed, I think you should get everything right. Okay, that's the safest thing to do. Okay, guys, so let's continue. So remember when I started the session way back, um, I said that whenever you see an algebra based question, observe the given questions. And I said, ask yourself three questions. What kind of equation? What do I do to simplify the equation and work towards the question, right? We looked at what is the guidelines to simplify algebraic equation. I'm going to explore a little more in why I said figuring out the kind of equation is important, because you broadly would have three kinds of equations that the GMAT would test you on: linear, simultaneous, and quadratic. So let's first look at linear equations. Now, when I'm discussing linear equations, again, guys, I'm sticking to the process of algebra. I am not, you can actually represent these on the XY plane in coordinate geometry as well. Any algebra concept can be plotted on the XY plane. I am not dealing with the visual way of working of coordinate geometry. I'm going to stick to the straight and narrow with simple equations. Okay. I may reference something with coordinate geometry, but I'll explain that to you. Now, linear equations, I said, are degree 1 equations of the form ax plus by is equal to c. Now, when you see linear equations on the GMAT, right, the GMAT can only test you on linear equations in one specific way. It's going to test you on your decision making. What decision will you have to make? The decision that you'll have to make is whether you have to solve the given linear equation or not. This is the big decision that you'll have to make. So let's say I give you this equation. Let's start with a simple equation. 2x plus 3y is equal to 12. Now my question to you all here is this. Is it possible, I want you to listen carefully, is it possible for me to solve this equation? Remember, this equation has one equation with two variables. Is it possible for me to solve this equation with two variables and get to one unique solution? So my question, is it possible for me to solve this linear equation with two variables and get to one unique solution? Yes, no, maybe, unsure. What do you think? No, no. Akshat says yes. So guys, those who are saying yes and no, can you also justify your answer? Faizan said no, Tushar said no, Akshat said yes. So can Tushar, can you justify? Akshat, can you justify? If you're saying no, tell me, you're telling me that you can get multiple solutions. So at least prove to me there are multiple solutions. You're telling me yes, you can solve. Then you're telling me you're only getting one solution. So if you're getting one solution, tell me what the solution is and why not, why can't there be other solutions as well? It will form a straight line on the graph. Okay. I will touch upon that a little bit later, if we can use intercepts concepts. Guys, forget about the visual representation at this point, right? My question is as straightforward as this. Is it possible for me to solve this equation and get to solutions of x and y? Yes, you can try x is equal to 1, 2, 3. See, the biggest problem that I see that most of y'all are looking at, right? I mean, you're not opening your mind up towards looking at what possible values I can take. I did not tell you that x and y only have to be integers, right? So why only 1, 2, 3? I can also have decimals, right? They are also part of the number line, correct? So why only numbers, integers? So Manas says two unknowns. I'm going to break that. I'm going to break that. Say misconception that if you have two unknowns and one equation, you won't be able to solve. Yes, not possible. We'll get infinite solutions. The reason why we would get infinite solutions would be because there are no limitations that I've put on what values x and y take. X and y can take decimal possibilities as well. And if x and y can take decimal possibilities, there are so many decimals that when multiplied by 2 and when multiplied by 3 will add up to 12. So I'm never going to get one unique solution. I'm going to get multiple possibilities. Some of you all did put in values as well, set 0, 4, 6, 0. That was also a good way to work. But there again, you're limiting your thinking only to integers. So I agree with you. This equation on its own is not going to be enough because I have multiple possibilities. But what if I now put this limitation? I give you the same equation, but I put the limitation that x and y are positive integers. And I ask you the same question. Is this linear equation with two variables going to be enough for me to solve for x and y and get to one unique solution? If you're telling me no, it is not possible, then you have to prove to me that there's more than one solution. If you're telling me yes, it is possible, show me that there's no other solution. So again, my question stands, guys. I'm just changing the question slightly. I'm keeping the equation exactly the same, but I've put a limitation that x and y are positive integers. Would that equation on its own be enough for me to solve for x and y and get to a unique solution? So Faizan said no. Ramakrishna said no. If you're telling me no, you have to prove to me there's more than one solution. I will not accept no. 3-2 is the only answer, says Nivedita. So Nivedita, why is there no other solution? We need intersection of two lines to find one unique solution. No, Vrishabh. No, not necessarily. And that's the misconception I want to break. That's why I said don't look at it in terms of coordinate geometry at this point. Remember, guys, coordinate geometry, when you look at things on the coordinate plane, all points are open to you. I'm limiting the points to integers, positive integers. And I'm asking you whether you'll be able to get to x and y points that satisfy this equation. It is a straight line. So what if it's a straight line, Ramakrishna? My question is, given the limitation that x and y are positive integers, can I get to a solution? So if you're telling me no, it is not possible, you have to show me how there can be any other solution. Yes, 3 and 2 are the only solutions to this equation. X is equal to 3, y is equal to 2. For those who plugged in and worked, we'll look at how people got x is equal to 3, y is equal to 2 in the discussion as well. For those who are wondering, why can't I put x as 0 and y as 4? I've said specifically positive integers. Exactly. I've said positive integers. 0 is neither positive nor negative. So I cannot have those as possibilities. So that's the point I'm making. That is why I said it's about decision making, whether you solve or not. How do you make that decision? If you have a linear equation where there are absolutely no integer constraints, don't bother wasting your time with it. When there are no integer constraints, basically decimals are also a possibility. Just don't solve or just discard. Don't bother wasting your time. But as soon as you see a linear equation where you have integer limitations. Where you have integer limitations, you have to solve, you have to chase these equations. And you have to solve by plugging in values. We look at how smartly to plug in values. I'm going to put in a process here. It's a little complex, so bear with me, right? I'll explain it well. So whenever you see integer constraints, I would always solve. These are what we call, when you have integer constraints on equations, these are what we call Diophantine equations. Very fancy name. I think named after some Egyptian king or queen, I'm not sure. So it's called a Diophantine equation. You have to be very careful of these Diophantine equations. Simple rule: you see a linear equation, you see there are limitations that apply, integer limitations that apply. Do not discard it, saying that I cannot solve one equation with two variables. No, you can, if integer limitations apply, right? Now, let me actually keep that the same. Now, for those who said 2x plus 3y is equal to 12, got the answer very quickly. Good. I think you got comfortable with numbers. You got the answers as 3 and 2. But how would you solve? How did you solve? Did you just randomly put in values? Did you put in values as a hit and trial process of working, or was there like a process in which you worked with? If y is 1, then x cannot be greater than 4.5. Yes, that's one way of looking at it, Pratik. That's a good way to look at it. So one, I'm assuming all of you all have understood that why I would chase this equation. As soon as I see that integers apply, positive integers apply, I'm going to chase this equation. And if I'm chasing this equation, I would want to plug in values. Now, there are two ways of working with such a question. Okay. The first way is to try to get to a very simple solution to this. Okay, this is exactly how you work with Diophantine equations. What are Diophantine equations? I don't want to make it too mathematical. So Diophantine equations are basically equations of the form ax plus by is equal to c. Right? And they are reduced to the lowest form, and x and y will always be integers. These are what we call Diophantine equations. When you see Diophantine equations, the smartest way to solve is to immediately get to one solution, one quick solution you get. Doesn't matter if it satisfies the constraint or not. Get to one quick solution. So looking at this, I know the quick solution I can get is x is equal to 6 and y is equal to 0. I know I cannot use it. I know I cannot use this. But I know quickly I can get to x is equal to 6 and y is equal to 0. I know this is not going to be a solution, but from here, I can get to all the other solutions. Okay. What do I do? What will I do? Once I get to one solution to my equation, the coefficient of x is 2, the coefficient of y is 3. Subtract the coefficient of x, subtract the coefficient of y from the solution you got for x, and add the coefficient of x to the solution of y. So what do? You want to find other solutions. You've got x is equal to 6 and y is equal to 0. The coefficient of x is 2. The coefficient of y is 3. So I want to reduce the value of x and I want to increase the value of y. So what will I do? To this solution of y, I will add the coefficient of x. And to this solution of x, I will subtract. You have to always add on one side, subtract on the other. I'm going to subtract. Because I need to reduce this, I need to increase this. I'm going to subtract the coefficient on y. So x will be 3, y will be 2. This is my other solution. And this will definitely satisfy my equation. I'm not plugging and playing, Tushar. I'm not plugging and playing. That is the worst way you can work. I'm going to give you more difficult equations than this. And if you try to plug and play there, you'll never be able to solve. Right? Plugging and playing is not a very good way of work. There has to be a structure to the process of working. So what did I do? I quickly got to one solution. Doesn't matter. I know that's not the solution, but one solution that satisfies that equation. What did I do from there? I'm trying to get to the other. To the value of x, I subtracted the coefficient of y. And to the value of y, I add the coefficient of x. So x is equal to 3 and y is equal to 2. Now, if I want to know there are more solutions, again, I'm going to reduce this further and I'm going to increase this further. So again, I'm going to subtract 3, the coefficient of y, and I'm going to add 2, the coefficient of x. So here I'm going to get x is equal to 0, y is equal to 4, which I cannot consider because I've given you x and y are positive integers. And I know I'm going to stop at this point because if I reduce this now further by minus 3, and if I reduce this further by a minus 3, then what's going to happen? It's going to go into negative zones, both of which I cannot do. Right? So you see, I've got to my solutions. I've got to my solutions. So this is one way to work. Get to a solution and then use the Diophantine way of working and break it down. Another way to get to a solutions, again, is to not plug and play. We'll again take this, we'll take another example and we'll work with all the processes, okay? Another way to work with such solutions, if you want a quick solution to it, analyze the equation based on evens and odds. That's another good way to work. You can always use this evens and odds process when you have an equation where the coefficient of the variable is even. So I know 2x is always going to be an even number. 12 is an even value. And I have 3y. So if 2x is even, 12 is even, 3y also has to be even because even plus even can only give me an even. For 2x to be even, x can be any value I want because 2 times any integer value will always be even. But for 3y to be even, y has to be even. So there's a limitation on what values I can put in for y. So I know y has to be even. So the first value I can put in for y, I can't use 0 because y, x and y are positive integers. So I can put in y as 2. So 2x plus 6 is equal to 12. I'll get x is equal to 3. So x is equal to 3 and y is equal to 2 is a possible solution to that equation. Right? Now, if I put y is equal to 4, that's the next even value. If I put y is equal to 4, I'm going to get 2x plus 12 is equal to 12. It will give me x is equal to 0, which I cannot have. So I know y is equal to 4 will not work. And the next value I'm going to put for y has to be y is equal to 6, right? Because it's even. Y has to be even. And I know if I put y is equal to 6, the value of x becomes negative. So I cannot have any other possibility after that. So there's only one solution to this equation. X is equal to 3 and y is equal to 2. Okay with this? So you can analyze it as well based on evens and odds. You don't need to plug in values. Random plug and play is not a very nice process to work. Because if I make the equation a lot more difficult, let's say, and this is for all of you all saying I can still plug and play. Let's say I give you this equation. Okay, we look at different variations. Don't worry about that. So I'm going to make this equation a little more harder. 7x plus 6y is equal to 78. For those who are still saying, let me plug and play, try it with this question. You're going to find it very difficult for you to get to one solution. And on top of that, even if you get to a solution, right, you're going to be doubtful on whether that's the only solution or not. So let's look at this together again. If you want some time to work with it, you can, but let's look at it both ways. I want to get to one solution to this. Remember, if I want to use the Diophantine process of working, I need to get to a baseline solution. And from that solution, I can reduce one, increase the other based on the coefficients to get to the other solutions. Right? If not, I can analyze things based on evens and odds and then continue doing that because I have the coefficient to be even. So what do you want me to work with first? if I want to work with evens and odds, remember evens and odds, if I work, I can get to one solution. It's not very easy for me to get to one solution of x and y here just by looking at it. Remember, the Diophantine process requires you to get to one solution first and build from there, right? Now, how do you figure that out? How do you figure out how many solutions an equation will have? Now, let's write it down here so that you're clear about things. So when you're working with a Diophantine equation, that is an equation where a linear equation where you have integer limitations that apply. First step, ensure that you reduce the equation to its lowest form. That's the first step, right? Set it up in the form of ax plus by is equal to c. There should not be any common factor between a, b, and c. Once you set this up like this, you see here I have 7x plus 6y is equal to 78, right? So it's already reduced to its lowest form. You know you have to chase this equation, but I can figure out how many solutions are there. If you take the value of c divided by a times b, so what do we have here? 78. A times b, 7 5 is 35, 7 6 is 42. If the value of c divided by a plus a into b, say 78 divided by 42 is 1 point something, the value is between 1 and 2. So based on the value that you get for c divided by a into b, you will be able to comment upon how many solutions are there in this equation. Since your answer here of 78 divided by 42 is between 1 and 2, you should get at least one solution or at most two solutions. So a quick view of the equation and taking the value of c divided by a into b will tell you how many solutions you can get. So here I'm getting a value between 1 and 2. So there's going to be at least one solution here, but there can be at most two solutions. So there can be one solution or two solutions. I'm unsure. I have to solve for it. So that's the first step. Reduce the equation to its lowest form. And second, find the value of c divided by a into b. Of c divided by a into b. If the value of c divided by a into b is between 0 and 1, there will be either no solution or there will be one solution. If the value is between 1 and 2, between 1 and 2, then you'll have at least one solution or at most two solutions. If you have it between 2 and 3, you'll have at least two solutions, at most three solutions. So you're looking at it, 78 divided by 42 is between 1 and 2. That would give me minimum one solution, maximum two solutions. I need to find that out. Now here I can't just randomly put in some values and work with it. So what will I do then? Find one solution, one easy solution to the equation. Either by using 0 to your advantage. Here I can't use 0. Unfortunately, if I use 0 here, 7x will not go to 78. If I use 0 on x, 6y will not go to 78. Or you can use the evens and odds to get to one solution. Or you can use something called units digit. You can analyze things based on units digit to get to one solution. Find one easy solution. Since I see the coefficient as even, I know this is even, this is even. So this also has to be even, because even plus even can only give me even. And if 7x has to be even, x has to be even. So there's a limitation on what values I can put in for x. So the first value I can put in for x is equal to 2. 7 2s are 14. 78 minus 14 is a 64. 64 is not divisible by 6. So I know that's not going to work. If I put x is equal to 4, 7 4s are 28. 78 minus 28 is a 50. That's not divisible by 6. If I put x is equal to 6, 7 6 is a 42. 78 minus 42 would be 36. 6y would be 36. So y would be 6. So that's my first solution. X is equal to 6 and y is equal to 6. Now I don't need to go on plugging in values and checking for other possibilities, right? At this point, I would say, okay, for me to get more solutions, I want to increase the value of one and decrease the value of the other. So let me choose to decrease x and increase y. How would I decrease x? I would subtract the coefficient of y out of it. So minus 6. So x will be 0, right? And increase y. So what will I get? If I want to work with x, I'm going to subtract y and I'm going to increase y for 7, right? So I'm going to get x is equal to, what do you think? Y is equal to 6 plus 7. So y is equal to 13, right? That would give me the 78. You could have put x is equal to 0, y is equal to 13 as well in the first case. So I've got x is equal to 0 and y is equal to 13 as another solution, but I cannot take that into consideration. I have to discard it because it's positive integers. And I know anything I reduce further, if I reduce this by 6 and I increase this by 7, the value of x is going to become negative. So there's only one possible solution to this equation. X is equal to 6 and y is equal to 6. So either find an equation, get to an equation. If you want to work with Diophantine equations, get to a solution, either by using 0 or by using evens and odds or by analyzing it from units digit. Once you get to your solutions, right, simple process. For the solution of x, add or subtract the coefficient of y. And for the solution of y, add or subtract the coefficient of x. Got it? Yes? Let's try one more question. I'm going to make it even harder. Okay, so let me pick a value here, right? So let's say we have x and y are positive integers. 19x plus 25y is equal to 1000. I want all of you all to give it a shot, please. Okay, try it out. Guys, get to one easy solution first, right? And from there, do the process. If you get to one easy solution, to the value of x, either add or subtract the coefficient of y, and to the value of y, either add or subtract in coefficient of x. If you're adding for x, subtract from y. If you're adding to y, subtract from x. So would this have only one solution or would it have multiple solutions? That's the question. Yes, very good. Yes, Amriti, two solutions. So the first thing I want you to note is I have to chase this equation. Why? Because it is a Diophantine equation. I have integer limitations on that linear equation. Second, if I want to work with it, is using the Diophantine process, reduce everything to its lowest form. Get to one easy solution. And from that solution, get to the others. Very good. I see most of you all have got that process. The easiest solution here would be x is equal to 0 and y is equal to 40. I think all of you all would have got to that because it's a multiple. See, getting an equation where you have like a coefficient of 5 or a 10 is actually very good for you, right? Now from here, I would want to reduce the value of y and I would increase the value of x because I'm dealing with only positive integers. I know this is not going to be a solution, but that's a start point for me. So if I'm going to increase the value of y, I need to add the coefficient of x. I mean, if I'm going to increase the value of x, I need to add the coefficient of y. And if I need to reduce the value of y, I need to subtract the coefficient of x. So 0 plus 25. So my next solution will be x is equal to 25, y is equal to 21. That's definitely a solution. You can put it back in and you can test for it. And next, again, I would want to add 25 to x, subtract 19 from y. So x would be 50, y would be 2. That's also a possible solution. Waiting from 6th standard. All right. So I'm not going to go further from here, right? Because if I know I increase the value of x further, and if I decrease the value of y, it's going to go into negative zones. So this equation I know has two solutions, right? And obviously I don't get to one unique answer. Vrishabh, I told you I'm not going to explain the concept geometrically. I can, but this is not the time and place. It would just deviate from the process. When maybe I have a quarter geometry is one is I really like the topic. I would want to visually work with it, but I'm refraining myself from doing so because I don't think everyone will be able to get that at this point. Okay, so I want to stick to the algebra bit so that everyone knows that no matter what, they'll be able to solve it with algebra or with pen and paper other than drawing certain things out. Okay, all right. Great. So let's. You want one more equation, or we can dive into a question. So, guys, just quick before we go in to a question. Um, is it true that if I have one equation with two variables, I will not be able to solve? Can I just discard it? So, for those of you all who had that thought process, is it necessary for an equation with two variables to need another equation to solve? One equation with negative values. Think about it, right? I mean, you can go with negative values as well, right? For example, you got x is equal to 50 and y is equal to 2 in the previous question, right? So you could have gone further. You could have you could have increased 25 and reduced 19 again, right? It would have given you the negative solutions as well. But think about it. No, the GMAT is not going to expect you to work with all the solutions, right? It's a line, like somebody said. A linear equation is a line, so you will have multiple integer solutions, right? They will limit it in such a way that that equation can be solved by getting one value. Okay, good. All right, so let me shift to the PPT. I'm hoping everybody can see this. Guys, I've written the entire theory here for you all to refer. So once you get the PDF, you can use this, you can take a printout and you can work with it. Here's your first question. Give it a shot. I'll give you all 2 minutes. Remember, one thing I want you to understand, nobody is going to ask you 2x plus 3y is equal to 12, give you an equation and say, is it solvable? Correct? Everything is going to be in the guise of a word problem. You'll have to break down the word problem, get to a linear equation, and then you'll have to think about whether you're going to chase it or not. The first question you need to ask yourself is, do I chase this equation? Is it a Diophantine one? If it is, break it down like the way we discussed. Give it a shot. I'll give you all a couple of minutes. Yes, it is very useful in data sufficiency, Pratik. That's the purpose of me putting this. Okay. Okay, you can start typing your answers in the chat window, please. Okay, I'm getting different answers. Guys, remember the questions asking you what is the greatest number of pieces of fruit that a customer can purchase at the stand, right? So the safest thing would be for you to list out all the solutions, and the solutions have to be positive integers because buying fruits, and you can't assume that he's bought on he can buy 0 apples and oranges as well. So don't forget about that as well. Okay, 13. Okay. Okay, I see a very mixed bag set of answers. So let's work with it, right? A certain fruit stand sells. Remember, guys, I did not, I did not discard the 0 here, right? I want you to understand that. At no point have they told me that that I need to pick apples and oranges, right? They've only told me you have to pick only apples and oranges. I can pick 0 apples and whatever oranges as well, right? So I've just said X and Y have to be non-negative integers here. 0 is also a possibility that you can consider. Now, what is the equation? I'm sure all of you all made this equation, right? You said 30A plus 40O is equal to 470. Yes, most of you all did this. 30 cents is 0.30, so I can remove the 0 as well. So that's 3A plus 4O is equal to 47, correct? So quickly I'll try to find a solution. I can't put A is equal to 0 because 47 is not divisible by 4. I can't put O is equal to 0 because it's not divisible by 47 is not divisible by 3. But I know this is even. Let me get to one solution first. Smartly. This is even. This is odd. So this has to be odd, right? Odd plus even can only give me an odd. And for 3A to be odd, A has to be odd. So I'll put A is equal to 1. If I put A is equal to 1, this will become 3. So 4O plus is equal to 47 minus 3, which is 44. So O will be 11. So this is my start point, right? This is one of my solutions, a legitimate solution. But the question is asking me what is the greatest number of pieces of fruit that the customer can purchase. So I need to figure out, right? At this point, it's 12, but I need to see what my other solutions are and see whether they give me an addition that is more than 12. So what am I going to do? To the value of A, I'm going to increase the value of A. I'm going to reduce the value of O. So if I'm going to increase the value of A, I need to add the coefficient of O. And if I need to reduce the value of O, I need to subtract the value of A. So A can be 5, O can be 8 as well. Again, I'll increase by 4, I'll reduce by 3. So A can be 9, O can be 5 as well, right? So I'm increasing by 4, reducing by 3. Again, increasing by 4, A can be 13, O can be 2, right? I've reduced by 3. And then I can increase by 4 again. If I increase by 4, A can be 17, but O will be minus 1, right? So is it possible for me if I go further than this? I'm going to increase it by 4, that's 17. And this I'm going to reduce, that will go into negative zones, minus 1. So I have 12, 5 plus 8 would give me 13, 9 plus 5 would give me 14, 13 plus 2 would give me 15. I cannot consider that because I can't have negative oranges. So B should be my answer. All right, everyone. Very good question. Makes you think a little out of the box. I don't need to plug and play. That's the most important takeaway, right? I don't need to plug and play if I understand the process of how to work with a Diophantine equation. Okay with this, guys? Any doubts on this? We may have to skip over the data sufficiency question, but I think once you get the PDF, please try it out with this process. I think it would be very easy for you to work. So we'll skip over and we'll look at simultaneous and we'll look at quadratics as well. Okay. Pratik, I know what you're speaking about Max-Min, but to be very truthful, right? I mean, I can do Max-Min in two ways. Max-Min can be used as differentiation as well. You can also think about the maximum value of X and the minimum value of Y and then work from it as well. But I prefer this process of working. Okay. I would want to reason things out, get to one solution. Once I get to my one solution, I can get to other solutions. Got it? All right. So I do have a data sufficiency question. I do have another question, but let's move forward. I want to focus on the concepts. All right. So let's again debunk some myths about simultaneous equations as well. I'm sure all of you all will know what simultaneous equations are. Some of you all will say simultaneous equations are equations where there are more than one equation. Some of you all will go into the xy plane and say they are intersecting lines on the xy plane. Both fair enough definitions. But how does the GMAT test you on simultaneous equations? Obviously, it will test you on how you master the conventional process of working, right? Where are you going to get simultaneous equations? If you ask me, simultaneous equations are the most prevalent that you get on your test. All your topics of word problems, time and work, speed, distance, time will boil down to simultaneous equations, right? So the first thing you're going to be tested on is the conventional approach. And you're going to be tested on the conventional approach. What is the conventional approach of working with simultaneous equations? See, whenever you have more than one equation, you can either equate the coefficients. Why do we do this? Why do we equate the coefficients? What we try to do when we have more than one equation, let me write that first. We try to boil the equations down to one variable, right? You boil it down to one variable. And how can you do that? By either equating the coefficients or by substituting one equation into the other. This I'm sure everyone will be well versed with when it comes to working simultaneous equation. But what the GMAT tests you on, right, is two things. It tests you on how smart are you going to work with the equations? How smartly are you going to work with the equations? So let's take an example of an equation, right? Suppose I give you two equations like this. 2x plus 3y is equal to 12. And I give you 7x plus 5y is equal to 60. And I ask you to solve for x by y. How would I go about this? Now, what I want all of you all to focus on is this. I don't want to solve it is in the conventional process. Everybody will know how to work with it. You will multiply the first by 5, you will multiply the second by 3, you will make y equal, you will cancel it out by subtracting, you will find x, then you will take that value and substitute and get to the other. The question, remember, here is not asking you Remember what I told you in the beginning. Focus on the question. The question gives you a clue on what you need to do. The question is not asking you to solve for x separately and y separately. It's asking you to solve for x divided by y. What is the meaning of x divided by y? I need a ratio between x and y. So I want you all to keep an open mind and not limit your thinking on simultaneous equations only to equate coefficients or substitute one equation into the other. You can manipulate equations the way you want, but the best manipulations are always based on what the question is asking you. The question gives you the clue. The question is asking me to solve for a ratio between x and y. A ratio is a relationship between x and y. Something like 2x is equal to 3y would give me the ratio of x by y is equal to 3 by 2. I want a relationship between x and y. And the only way I can get a relationship between x and y is if I have an equation where there's only x's and only y's. There's no constant involved. So what can I do? Instead of sitting and solving for it, right? I can say, okay, I need a relationship between x and y. Let me get rid of the constant because I want an equation where there is absolutely no constant. So I'm going to multiply my first equation by 5. So 10x plus 15y is equal to 60. I have 7x plus 5y is equal to 60. So since the right hand sides are equal, I can say 10x plus 15y is equal to 7x plus 5y. So 3x is equal to minus 10y. I'm going to get x by y is equal to minus 10 by 3. That would be my answer. So you see, I did not, as a first mode of approach, I did not dive right in and said I'm going to use the conventional process of working. I took a step back. I looked at what I had. I looked at what my question was asking me. And then I manipulated the equations based on my question. So when you work with simultaneous equations, right, that's the skill set that you need to hold on to. Put the equations one below the other. It will always help. Placing the equations one below the other will always help. Don't dive right in. You can go back to the conventional process whenever you want. But then focus on what the question is asking you. The question gives you the clue. And based on the question, keep an open mind. You can manipulate equations the way you want. Choose the right manipulations to work towards what the question is asking. If it's want x by y, y by x, remove the constant. Let's take another example. Let's say 7a plus 11b is equal to, this is a equation that I'm pulling from an exact official question. Okay, it's a equation, it's a question from Time and Work. So the equations that you end up getting is 7a plus 11b is equal to, let's say, 300, and I have 8a plus 22c is equal to 500. And the question asks you to solve for these two equations and get the value of a plus b plus c. I want you all to take 30 seconds. Try working with it. Try using what I said. Don't dive right in. Observe what you have. Do the simple things. Remember, always reduce things to the lowest form. Look at what the question is asking you, and then see how you want to manipulate the equations. My mobile is switched off, so I'm not able to see the comments. Just let me get another mobile. I want you all to work with a question here. Okay, I'm back. Take your time, guys. Observe the equations first. Don't dive right in. Observe the first equation. Observe the second. Right? Do the simple things, reduce things to the lowest form, focus on what the question is asking, and then based on the question, choose how to manipulate. Again, for people going with the assumption that I have three variables but only two equations, I'm debunking that for you again. Don't say I need one more equation to solve. Okay? I still see others still stuck. Observe the equations. Observe the first, observe the second. What do you observe in the second equation, guys? What do you observe in the second equation? That I can simplify it to its lowest form. Do the simple things, right? Don't get into trying to solve it immediately. So 7a plus 11b is equal to 300. I cannot do anything with the first. But with the second, I see it's 4a plus 11c is equal to 250. I'm dividing the second by 2. And then I look at it, I see I need a plus b plus c. It's not asking me to eliminate any of the variables. The question gives you a clue. If the question had asked me to eliminate any of the variables, I would think of subtraction and division operations, because subtraction and division operations eliminate variables for me. But here, they're asking me for a plus b plus c. And I see if I just add the two equations up, I would exactly get what I want. It would be 11a plus 11b plus 11c is equal to 550. And since I need a plus b plus c, I'll take the 11 common. A plus b plus c would be 550 divided by 11, which would be 50. And that would be my answer. You see? That's the point I'm making. This is what you're going to be tested on in simultaneous equations. You're going to be tested on how smartly are you going to be able to use your pieces of information and manipulate them to get to what you want. Again, what did I focus on? I focused on observing. I focused on doing the simple things of simplifying things to the lowest forms. And I then focused on what the question was asking me to solve. And based on my question, I chose the right manipulations. That's the first thing I want you to hold on to in simultaneous equations. Okay? Work towards the question. Place things down one below the other. Do the simple things. Simplify to the lowest forms. Focus on what the question is asking. Based on the question, keep an open mind. Try to manipulate the equations based on what the question is asking you to solve for. Okay with this? This is the first. And what is the second thing that you're going to be tested on in simultaneous equations? So my question to all of you all, especially people who look at algebra in terms of coordinate geometry, can all linear equations, or let's say if I give you two equations with two variables, will you always be able to solve two equations with two variables? Will you be always able to solve two linear equations simultaneously? Think about it. Guys, can you always solve two linear equations simultaneously? If I give you one equation with x and y, and I give you another equation with x and y, would you be able to solve them simultaneously every time and get to one unique solution for x and y? Or would there be exceptions to it? Yes. So the second thing, never assume that linear equations can always be solved simultaneously. Don't assume that you have two variables with two equations, you can solve it. Can be always solved simultaneously. Always cross-check. Always cross-check if the equations are unique. Basically, you have to take care of the parallel line scenario. Somebody said that linear equations are, somebody said, lines on the coordinate plane. Simultaneous equations are intersecting lines. Two lines can always intersect at only one point, but there is a case where two lines can never intersect when they are parallel. So without plotting it out, how do you figure out from the equations that you're dealing with parallel lines? If I have two equations in the form a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2, if the ratio of a1 by a2 is equal to b1 by b2, then this would always represent parallel lines. You will not be able to solve these two linear equations because you will never get to a solution. But if the ratio of a1 by a2 is not equal to b1 by b2, then they will always be intersecting lines. And lines can only intersect at one point, so you can definitely solve. Very, very important from a data sufficiency perspective. Okay, don't assume that when you have two linear equations with two variables, you can always solve. Always do the extra bit, cross check if those equations are unique or not. Check for the parallel line scenario. Okay. All right. And finally, quadratic equations. We'll work with both and then we'll look at a couple of questions and wrap up. Still, I see 60 people there, so thank you for this. Okay. I want to finish what I came with the mindset to discuss quadratics as well. So let me finish that. We'll work with a couple of questions and then wrap up. Okay. Let's pull on for maybe another 15 minutes. When you get quadratic equations on the GMAT, whenever you see a quadratic equation, a degree 2 equation, your focus should always be on try and factorize the equation. Always try to factorize the equation. It doesn't matter how many variables you have. If it's a second order equation, I will always have the opportunity to factorize. So I have to be clear about the process of factorization. Right? I'm assuming all of you all are okay with the process of factorization. If I give you an equation 2x square minus 9x plus 10 is equal to 0, how many of you all are comfortable solving such a quadratic, and how many of you all are not very comfortable solving this quadratic? All of you all know how to work with the process of factorization. The process of factorization is, and this holds good for any quadratic equation that can be factorized, the process is always multiply the first and the last term. So plus 20x square. If you have a coefficient, this is what you do. Multiply the first and the last term, right? Always multiply the first and the last term. You get the product plus 20x square. This is the correct process that I'm putting forward, okay? Multiply the first term and the last term. Be careful of the sign. And you need to split this product into two values which add up to your middle term. So clearly 5 4s are 20. So this would be minus 5x and minus 4x. And then I factor this out this way, right? So 2x, I think I take x common. I should have flipped the terms around, but it's fine. X into 2x minus 5 minus 2 into 2x minus 5. So x minus 2 into 2x minus 5 is equal to 0. So x is equal to 2 or x is equal to 5 by 2. These would be my two solutions. So what I'm doing here is the right process to break down any quadratic equation. Okay, always multiply the first term and the last term, take the product, split that product into two values which add to your middle term, and then factorize it by pulling things out common and making it into a product of values. And these values are what we call roots of the equation. Right? So whenever you see a question Remember, the roots of an equation will always satisfy the parent equation. So in a question that deals with a quadratic, if the root or roots are given to you, you can always substitute the root in the parent equation. Always remember this. Okay, whenever you see a root given to you in a question on a quadratic, you can always substitute it into the parent equation. That's the first. The second thing you're going to be tested on is how you're able to identify a hidden quadratic equation. Now, what is a hidden quadratic? You can have an equation that can be boiled down into a quadratic form. For example, let's say I give you x square y square minus 5xy plus 6 is equal to 0. Now, if people are uncomfortable working with this equation, then I'll show you a way to work. But for people who understand quadratics, remember I just told you any equation with degree 2, you can always use the process of factorization. You can multiply the first and the last, take that product, and you can split that into the middle term. But if you're uncomfortable doing this, then if you have a second degree equation and in your mind you know that all quadratic equations are in the form of ax square plus bx plus c is equal to 0, you can always set this kind of equation into the general form. How? By making a smart substitution. So you need to learn to identify hidden quadratics. I'll show you. There are much more harder equations than this. And how do you identify hidden quadratics? This is the best way to identify them. When you see an equation where the power of one term, you have an equation where the power of one term is half the power of the other. These equations are very good candidates for me to break it down into a quadratic. I can always represent these equations in a quadratic form. How? By making a smart substitution. By making a smart substitution. So what I can do is I can substitute xy is equal to a. You see, I can substitute this term as equal to a, make it into something that I can relate to. So this is going to become a square minus 5a plus 6 is equal to 0. And if I break it down, it would be a minus 2 times a minus 3 is equal to 0. So a is equal to 2 or a is equal to 3. So a is xy, so xy is equal to 2 or xy is equal to 3 would be the solutions to my equation. Now this is more of an easy question, right? But what if I give you something like this? T to the power of 4 minus 5t square minus 6. So let's say t to the power of 4 minus t square minus 6 is equal to 0. Now immediately when I look at this equation, I wanted to observe it. What do I notice? I have the power of one term to be half the power of the other. So I can still represent this as a quadratic. I can't use the quadratic process to work with the fourth degree equation, right? So I'm going to substitute t square is equal to x. So this will be x square minus x minus 6 is equal to 0. It's in the form that I recognize. I'll multiply the first and the last term. That's minus 6x square. And I want to split this into two values which add up to minus x. So that will be a minus 3x and a plus 2x. So x square minus 3x plus 2x minus 6 is equal to 0. So x into x minus 3 plus 2 into x minus 3 is equal to 0. So x is equal to minus 2 or x is equal to 3 would be my solutions. But remember, the solution is not for x here. The solution is about t. You need to solve for t is what the question is. So I'm going to replace x by t square. So t square is equal to minus 2 or t square is equal to 3. But you tell me, is it possible for t square to be equal to minus 2? Can a square ever be negative? Is it possible? Definitely not, right? A square can never be negative. So I have to discard this equation because that's not mathematically true. We don't deal with imaginary numbers on the GMAT. So t square is equal to 3 is a possible solution. So t would be plus or minus root 3. Don't forget the plus and minus possibilities. That would be the solution to that fourth order equation, right? So be on the lookout for hidden quadratics. Okay, once you're able to figure out the hidden quadratics, you'll be able to work with things in a much better way. But the question most of you all will have is, what if I'm not able to factorize the equation? If you're not able to factorize the equation directly, then obviously the equation is not conducive for using the factorization process. There definitely can be equations that cannot be factorized. For example, if I give you x square plus 5x plus 5 is equal to 0. Rhythm, it's not only under root 3, it would be plus or minus because it's a square, right? So if t square is equal to 3, t would be plus or minus the root 3. The plus or minus is not inside the root, it's outside. So if I give you this equation, right, x square plus 5x plus 5, I clearly cannot factorize it using the factorization process because even if I multiply the first and the last term, I'll get 5x square. And whatever I try to do, I cannot split the plus 5 into two values which will add up to a 5. It's not possible, right? So when you get an equation that cannot be factorized, then you use what we call the quadratic formula, which for those who know it, the roots of any quadratic equation is given by minus b plus or minus root of b square minus 4ac by 2a. This process of working helps me in two ways. One, it helps me factorize a quadratic equation that cannot be factorized using the quadratic process of working. But the most important bit, and this is what the GMAT will test you on, this process is called the method of the discriminant, because b square minus 4ac is called the discriminant. It's this what the GMAT will test you on. The value that the discriminant takes, gives me information about the types of roots. So if b square minus 4ac is equal to 0, then the roots are real and equal. You'll always have two roots which are the same. And if b square minus 4ac is greater than 0, the roots are real and unequal. You will get two roots, but those two roots will be two different values. And obviously, if b square minus 4ac is less than 0, then we say that the roots are imaginary. This is what you're going to be tested on. And how are you going to be tested on this? If you get a question, this is the important bit. This is the guideline. This is the important guideline. If you get a question that deals with a quadratic equation, and that question tells you or gives you the number of roots, it tells you something about the number of roots, right? It gives you or tells you something about the number of roots in the equation. The equation has, then immediately your process of working should be think b square minus 4ac. For example, if they tell me you have a quadratic equation x square plus bx plus 5 is equal to 0, and they say this quadratic equation has only one solution. So immediately I will say, since it has only one solution, b square minus 4ac should be 0, and I can build my question from that point. The GMAT tests you on this concept a lot. This and the next last concept that you're going to deal with. Whenever you see a question that gives you or tells you about the number of roots, When you see the number of roots given to you, think b square minus 4ac. Set the question up using b square minus 4ac. If they tell you this has one root, then b square minus 4ac should be 0. Build your question from that point. If they tell you have two roots, two different roots, b square minus 4ac is greater than 0. Build your question from that point. And finally, there are two properties of a quadratic equation as well. For any quadratic equation of the form ax square plus bx plus c is equal to 0, most of you all will know this. The sum of roots is always given by minus b by a. I'm not going to derive it. There is a derivation. I would have done it if I have time. And the product of roots is c by a. These are two properties of any quadratic equation. Whether you have a quadratic equation that can be factorized or a quadratic equation cannot be factorized. For any quadratic equation of the form ax square plus bx plus c is equal to 0, the sum of roots is always minus b by a. What is b? It's the coefficient of x. What is a? The coefficient of x square. What is c? The constant. What is a? The coefficient of x square. The sum of roots will always be minus b by a. The product of roots will be c by a. Most of you all will know this, I guarantee. If you didn't know it, it's good. You know it now. But for those who know this, right, the biggest problem will be where to use this. And that's what I'm going to give you as a guideline here. Where will this process come in very handy? Whenever I'm working with a quadratic equation and I have a question, I've been given a quadratic equation of the form ax square plus bx plus c is equal to 0, where a, b, or c is an unknown. If they give you an equation and they say, in the given quadratic, x square plus kx plus 5 is equal to 0. You see, they've given me the value for a, they've not given me the value for b. Or they can say x square plus kx plus y is equal to 0. They've given me the value for a, they've not given me the value for b, they have not given me c. Whenever you see a quadratic equation where a, b, or c is an unknown, and you have information, you have some sort of information about the roots, then always remember these questions. Whenever you have quadratic questions where you have a, b, or c or as unknown, you can always set up the question using the sum of roots or product of roots. This is where you're going to make use of this property. Okay, very, very important guideline. I wanted to think of working with this. Okay. So these are the guidelines that I wanted to hold on to for simultaneous and quadratics. Let's look at an example, okay, for the points that I've made. I'm going to pick a tough question directly. Let me see. Yeah, that's here. Yes, let's work with this. Okay, this is. Let me write this equation. I think there's a little formatting issue. Okay, so the question is, if there is exactly one value of a that solves the quadratic equation a square minus p minus 4 into a minus q plus 2 the whole square is equal to 0. That's your equation, right? Where p and q are constants. What is the value of pq? I can totally understand if you don't get this. It's a tough question, plus it's already late in the evening. I'm assuming all of you all would be, you know, saturated already. So this is the last question before we stop. So I want you to give it a shot, please. Try it out, 2 minutes. Remember, guys, the clue lies in the question. The clue always lies in the question. Focus on the question. I know it's a very daunting equation, but the question gives you a clue on what you can do to set things up and try to work from there. And then it's all the other algebra skill sets that we've discussed throughout the session that's going to come into play. Okay, I don't see any answers. I'm assuming all of you all are stuck at a point. So if you're stuck at a point, you can ping exactly where you're stuck at. If you're absolutely clueless on what to do with the question, that is also absolutely fine. P minus 2 and Q is minus 8. Q is equal to 8. Okay. B. Okay, somebody says B. Okay. Okay. Change to E. All right. Okay, how many of you all here read this first part? If there is exactly one value of A that solves the quadratic equation, this quadratic equation. So they're telling me that this equation has only one solution. So immediately when I know that there is one solution, what can I infer from this question? Guys, question to you. When I see that there's only one solution to this quadratic equation, what can I infer from it? Remember what we discussed in quadratics. First, identification of the hidden quadratic. That's clearly not the question type. Second, the quadratic formula, the application of the quadratic formula. And third, sum of roots, product of roots. You could have also used sum of roots and product of roots because this is a quadratic equation where A, B, or C is unknown. That is also possible. But when they tell me there's only one value of A that solves the quadratic equation, that means I know immediately that B square minus 4AC should be 0. So if B square minus 4AC is going to be 0, remember this is the equation. The equation is always in the form of AX square plus BX plus C is equal to 0. So basically what I have here is A is 1, B is minus of P minus 4, and C is minus of Q plus 2, the whole square. I would write that down, okay? It is a very difficult question, guys. It's a very high level question. I wanted to end with this because it basically, whatever we've discussed culminates into this question, okay? How you need to break down the question and draw inferences from the question, link it to the guidelines that we've discussed. And after you use the guideline, what we discussed from the beginning of the session, how you need to be smart about manipulation and how do you need to make a decision whether to solve or not. So I know B square minus 4AC is 0. What is B square? It's minus P minus 4 the whole square. So I'll remove the negative sign. So that becomes P minus 4 the whole square. Minus 4 times 1 times minus of Q plus 2 the whole square. And I know minus into minus will become plus. So that is P minus 4 the whole square plus 4 into Q plus 2 the whole square is equal to 0. This is what I have. Right? I've used the concept that we've learned. I've set this up. Now, this is where what we've discussed so far comes into play. I have this equation. Immediately don't get into opening up the brackets. I said, Pause. Look at what you have. Look at what the question is asking you. The question is asking you for PQ. Always work towards the question. Your process of working should be towards the question. Why would I not choose to split this open and work with it? Because no matter what I do, it is impossible for me, even if I open the brackets, to get to a term which has a PQ with it. I can't. I will not be able to get PQ, and I want to work towards my question. That gives me the clue that it doesn't make any sense for me to break this open. So if I can't work with it algebraically, if algebra fails, what is the next two best things I can do? I can analyze the equation, or I can put in values and try to solve. Right? Putting values is going to be a problem, right? If I you try to use my answer choices also, it's PQ, right? So I'll have to pick the correct combinations of P and Q that satisfies that equation. I can do it. It's possible. May not be the best approach. But whenever I see that I'm not able to break things down algebraically, I have to think out of the box. Like what we did in the previous questions, where people told me that I can't break it down algebraically. There's too many roots. I can use my answer choices, plug in, use my answer choices, and work. So here, I cannot break it down algebraically, because if I try to break it down, I cannot get PQ. It's impossible for me to get PQ. What I do when I'm not able to solve algebraically, I will always go into trying to analyze the equation. What do I observe? That is where observation comes into play. What do I observe in both of these terms in the equation? They both are squared terms. And squared terms will either be 0 or positive. I cannot have squared terms to be negative. And two squared terms added to give me 0 as the addition. The only way I can get two terms being added to give me a 0 is if one is a positive and one is a negative, both with the same magnitude. Or I have both terms to be 0. That's the only way. I cannot have the first case, because I cannot have a whole square term to give me a negative possibility. So what is the only possibility? This has to be 0 and this has to be 0. And when can those be 0? When P is equal to 4 and Q is equal to -2. That's the only possible solution. So PQ is equal to -8. That's my answer. This is exactly how a really, really hard question on the GMAT would look like. If you are getting these kinds of questions, you're doing really well on the test. Got it? And this is what I have, guys, right? My outlook towards algebra, how I look at algebra from a guidelines perspective, from a visual perspective, from an observational perspective, and a decision-making perspective. These are the skill sets: observational skill sets, decision-making, having an in-depth understanding of the question, and reasoning. These are the four skill sets that you need in addition to knowing the fundamental math. Got it? So this is what I had for today's session. I'm really, really thankful for all of y'all. There's 60 people here still at this godforsaken time of the night. I'm really thankful for all of y'all to stay up with me. I try to do go above and beyond, because I feel that I just don't want to finish the session in the time. I want to give you as many takeaways as possible. I hope this session has been helpful. I will ask the admin to upload this video as well for the people who it was too late. You can look at the recording. I will also provide the PDF of this PPT, so that you can attempt the questions that I also have selected that we couldn't discuss during the session. The guidelines are also there on one slide. I've tried to summarize everything on one slide. So all you can do is take a printout of that, post it on your workbench, and it would absolutely be like a revision of algebra. Okay. I will, Sweta, I'm not the admin. So I will ask Abhijit to do that. He's the admin. And once the video is up, I will ask him to, tag it in the comment section and make it the top comment so that everyone can download. Okay, guys. Thank you so much, guys. I loved being back. It's the first time in like 6-7 years I've actually taught classroom. Previously, I used to teach classroom sessions with 60-70 people, online sessions with many. It's good to be back, and I hope to see you in other sessions as well. There will be other sessions with me. Stay subscribed on the YouTube channel. You will get updates of my other sessions and other topics as well. All right. Good night. Have a good night's sleep, whatever is remaining of the night. I'll see you when I see you the next time. Thank you.